Well, hello everyone. Thank you for attending the Humanistic STEM Symposium today. We're going to start off our morning with an introduction from Dean Siedschlag, and then I will introduce today's agenda and the journey that we're going to go on together today, exploring this communication between the humanities and the sciences.
Good morning, and thank you, Christian. We have some in-person participants coming in, so give me a second to give them a chance, to give our in-person guests a chance to get settled. Thank you for coming. Others will be joining. We know academically it's still early, 9 a.m., but it's a packed agenda, and Christy made a great decision and a wise decision to put it all within one day, because otherwise life happens, and then we see, there is attrition on day 2, so it's a great idea to put everything in day 1. So, like I said, good morning, everyone. It's a great pleasure for me to welcome you to this year's annual Humanistic STEM Symposium here at Embry-Riddle Aeronautical University, brought to you by the Embry-Riddle Worldwide College of Arts and Sciences. As the College Dean, I want to thank you for joining us today here in our President's Hall, as I refer to it, but it's Henderson Hall, Henderson Building on Daytona Beach campus, if you are participating online across the country and throughout the world, and if you are participating as a presenter, a guest, a colleague, a student, or a curious explorer of ideas. Events like this represent something very important about our College of Arts and Sciences at Embry-Riddle Worldwide, and about the broader intellectual spirit we strive to cultivate here. They remind us that education is not merely about mastering disciplines in isolation. It is about discovering the deeper connections between them. And that is precisely what Humanistic STEM is about, and what we continue to be proud of. And our Humanistic STEM program, or the foundation for it, was originally laid by a National Science Foundation, an NSF grant, and out of which also emanated the annual symposium. That has had multiple iterations, but this is a particularly great one. Embry-Riddle's worldwide campus, College of Arts and Sciences, has long taken pride in being a destination for multidisciplinary study and impactful collaborative work, preparing students not only to succeed professionally, but also to become thoughtful and responsible global citizens. Humanistic STEM reflects this mission in a particular vivid way. Traditionally, we speak of STEM and the humanities as two separate intellectual worlds. One world deals with data, equations, engineering systems, and technological innovation. The other deals with culture, history, ethics, communication, and creativity. But the real world does not recognize these boundaries. The technologies shaping our future raise ethical questions. We know that very well. We experience that every day. Scientific discovery requires imagination. Engineering solutions must consider human behavior and social context. And innovation increasingly happens at the intersection of technical insight and human understanding. Humanistic STEM recognizes that the most important challenge of our time require both perspectives. The most important challenges of our time require both perspectives, the humanistic and the STEM perspective. Or, as we have referred to it, require both lenses simultaneously, both lenses, the humanistic lens and the STEM lens. At Embry-Riddle, Humanistic STEM is not simply a concept. It is an initiative that spans curriculum, student opportunities, scholarly engagement, and outreach, like in our symposium here today. It includes, our Humanistic STEM programming includes a minor, the Humanistic STEM minor, interdisciplinary course offerings, speaker events, the annual symposium, the 2026 occurrence of which brings us together today, and it's a particularly important occurrence because it is taking place during our university's, during our alma mater's centennial anniversary academic year. And this is actually our university's birthday month, because Embry-Riddle's official birthday is March 27th, 1926. So very important and meaningful timing. Through our HSTEM or Humanistic STEM activities, we aim to cultivate graduates who can think beyond academic silos, graduates who can combine analytical rigor with creativity, technological literacy with ethical awareness, and scientific reasoning with effective communication. Graduates who can navigate both the technical and the human dimension of complex problems. Today's symposium reflects that vision so beautifully. Looking at the program, we see a journey across multiple domains where science and humanities meet. We begin with algorithmic art, where computation becomes a tool of creative emergence. We move into storytelling and scientific imagination. We explore astrovisualization, where data from the cosmos becomes something we can see, interpret, and emotionally connect with. We examine public art in one of the world's most complex transportation systems and hubs, our Atlanta airport. We further explore the intersection of acoustics, engineering, and artistic expression. And we conclude with the fascinating MiG-21 Soviet-era fighter project documentary, exploring how historical aviation technology can inspire artistic interpretation and cultural dialogue to enhance resilience of societies. Taken together, these sessions demonstrate how science and technology amplify creativity. And creativity is rigorous, as it expands the ways we explore and communicate knowledge. Before we begin, I would like to express my sincere appreciation to those who made today possible. First and foremost, our Assistant Professor of the Practice and HSTEM Director, Christy Reynolds, who organized this year's symposium under her new leadership and her new fresh vision. Events like this require the energetic conviction that interdisciplinary exploration is worth the effort. Christy for sure has that, and we are very grateful for her leadership. I would also like to thank our presenters and contributors. Each of you brings a unique perspective that enriches our collective conversation today. Thank you for participating virtually from wherever you are and giving of your time, even if it's an odd time in your time zone. We appreciate that because we really strive to be worldwide. So thank you for being here virtually. By sharing your work with us, you are helping demonstrate how scientific insight, artistic imagination, and human curiosity can reinforce each other. And I want to thank all of you who are attending here on Daytona Beach campus and also online. Your participation is essential because the value of a symposium lies not only in the presentations, but in the conversations that they spark. In our college's strategic guidance, we emphasize several priorities that are directly reflected in today's event in our 2026 Humanistic STEM Symposium. One is the commitment to holistic and rigorous education that prepares students for real-world complexity. Another is the responsibility to foster ethical engagement with emerging technologies. And a third is the expansion of research, collaboration, and intellectual exploration across disciplines. Humanistic STEM embodies all the three. It reminds us that higher education is most powerful when it develops not only technical competence, but also curiosity, creativity, and cultural understanding. In the aviation and aerospace world that Embry-Riddle serves so prominently, this integration is especially important. The technologies that enable flight, space exploration, and global connectivity are among the most sophisticated achievements of modern science. But their success ultimately depends on people, on how humans design them, understand them, use them, and imagine their possibilities. Humanistic STEM therefore helps us answer a fundamental question. How can we communicate discoveries in ways that inspire others? That is why I find today's symposium particularly meaningful, and I'm grateful that our two department chairs of the departments that jointly lead the STEM, the HSTEM, the Humanistic STEM effort, are here. Speaking of communication, there is David Higgins, the chair of the Department of Humanities and Communication that also offers our worldwide online Bachelor of Science in Communication that has a technology communication specialization and also a crisis risk and resilience specialization. And the other department is the Department of Mathematics, Science and Technology. That is Christy Reynolds, our HSTEM director's academic home, but it is led by Tim Smith, who is here today. So thank you, gentlemen, for your joint effort in taking STEM, and our HSTEM, in taking our HSTEM initiative, taking STEM and the humanities, and then jointly the HSTEM program to the next level, and entrusting it to Christy. We are reminded that the spirit of discovery is not limited to laboratories or libraries. It emerges wherever curiosity, creativity, and disciplined inquiry meet. It appears where scientists collaborate with artists, where engineers think like storytellers, when historians analyze technology, when musicians explore acoustics. We all do that in our courses, including in the general education program that we so proudly deliver to all students of the Worldwide campus, and then also to all interested students from Daytona Beach and Prescott campuses. Universities exist to expand human understanding, and human understanding is rarely confined to one discipline. When we bring together science and the humanities, we are not mixing incompatible traditions. We are restoring a unity that has existed since the earliest days of scholarship. Let's take a moment to remember that. Leonardo da Vinci did not separate art from engineering. Early astronomers were philosophers, and the pioneers of flight combined physics, imagination, and bold vision. Humanistic STEM reminds us that knowledge grows most powerfully when different ways of thinking intersect and when things are simultaneously looked at through different lenses. So I hope today's symposium that, like I said, occurs during our university's centennial academic year inspires new ideas, new collaborations, and perhaps even new questions that none of us expected to ask before. Thank you again, Christy. Thank you again, our presenters. Thanks all of you for being here. I wish you a stimulating and enjoyable symposium. And with that, I will turn the program back over to Christy Reynolds to begin our exploration of humanistic STEM. Thank you so much. Thank you.
Thank you. Good morning, everyone, and welcome to the 2026 Humanistic STEM Symposium. I'm Christy Reynolds, Assistant Professor of the Practice in Physics at Embry-Riddle Aeronautical University Worldwide. This year holds special significance for Embry-Riddle. 2026 marks our centennial year, 100 years of innovation, exploration, and leadership. For a century, this university has advanced aviation, aerospace, engineering, and research at the highest levels. But today reminds us of something equally important. Progress is not powered by technical skill alone. It is also fueled by imagination, by ethics, by storytelling, by design, and curiosity. These are human capacities, and they are essential to STEM. I want to start by thanking the Worldwide College of Arts and Sciences for their generous support of this symposium. The College of Art and Sciences and the Dean's Office commitment to interdisciplinary engagement, especially in the centennial year, makes this gathering possible. Before we turn to today's program, I'd like to reflect briefly on something special that happened this past Saturday. For the first time, an event was held simultaneously at the Jim and Linda Lee Planetarium at Embry-Riddle Prescott and the Lowell and Nancy Lohman Planetarium at the Museum of Arts and Sciences here in Daytona Beach, presenting Dr. David Ibbott in a shared event across campuses. Dr. Ibbott's work transforms scientific data into musical experience. He invites audiences not just to calculate the universe, but to hear it and to feel it. To carry that spirit into today's symposium, I'd like to share a brief video that reflects this fusion of scientific insight and creative expression.
Hi, my name's David Ibbott, resident composer at the Center for Astrophysics, Harvard and Smithsonian, and I'm going to show you how we channel images of the deep universe into orchestral electronic music. This song, Luminosity, is part of the Voice of the Universe project. It was created using the first science image from the JWST. And as you'll see, it's a feast of color and rhythm. S-MAX 0723 is a galaxy cluster 4 billion light years away. And on the sky, the whole image is in fact less than the size of a grain of sand held at arm's length. Just look at how much is happening in one grain of sand. To help illustrate the richness and complexity of this image, perhaps music can shine a light. Now, you might think that the large star top left of the center is the focus of the image, but that's just a red herring. It's a local star from our Milky Way, given away by its diffraction spikes. These are distortions caused by the Webb's hexagonal mirrors. Instead, look closely at the center. The glowing blobs in the middle are in fact governing the entire image, like a cosmic conductor. If we add in the X-ray data from the Chandra X-ray Observatory, shown in blue, we can see how everything in the image seems to sweep around the center in radiant circles. This forms the baseline for our song. What you're hearing on the cellos and violas is a direct sonification of this blue data, where further from the center means higher in pitch. This blue blob is, of course, the galaxy cluster SMACS 0723, and it's 2.4 million times the mass of our Sun. These galaxies are engulfed in a sea of superheated gas that we can see only in X-rays. As we trace around the image, the cellos and basses play the central ring in staccatos, and the legato espressivo violas follow the outer edge. You'll hear at the top left there's a flurry of activity as the more complex blobs seem to escape from the central mass. At the foreground of the images are the bright and jagged stars, and we play those on the brass and the chimes. But what's at the back? This is what's most exciting to astrophysicists, and again, color and shape reveal the answer. These red shapes are not actually red. Each one is a galaxy, perhaps like our Milky Way, but they're so distant that their light has been distorted and stretched into redder and redder colors with lower wavelengths. Not only that, but when their light approaches the SMACS cluster on its way toward us, it's contorted by the power of gravity through a process called gravitational lensing. Each point is stretched out into a line, and some are even duplicated, forming almost concentric circles that seem to spiral and flutter around the central mass. These make for a perfect flute melody, played with acrobatic leaps by Jessica Smith. We can add that on top of our bass line to flesh out the image. Agnes Coakley-Cox, our voice of the universe, sings in the Great Refractor Telescope at the Center for Astrophysics, Harvard and Smithsonian. And this was once home to the Harvard computers, a pioneering group of women in the 19th and 20th centuries who made groundbreaking discoveries in astrophysics at a time where women were certainly not encouraged to enter the field. Agnes sings about how special our moment is in history and how lucky we are to be able to experience these wonders right now, and how in just one image we can learn so much about the nature of the universe. The magnification of these distant galaxies shows them in exquisite detail, so much so that we may, through a gravitational lens, be able to find the first stars to ignite in our universe, and one day understand the birth of stars and galaxies in the cosmic dark ages, some 13 billion years ago. So that's our story, told in one image, one sonification, and one song.
So it was a true honor to have Dr. Ibbott join us at both the planetariums in Prescott and Daytona Beach. He enjoyed the experience of interacting with Embry-Riddle students, faculty, and our general community, and he would like to join us again next year, hopefully in person at one of the planetaria. So what we have just experienced illustrates something powerful. When we translate data into sound, when we transform equations into imagery, when we turn complex systems into narrative, we can expand who can engage with discovery. Humanistic STEM does not dilute rigor. It deepens it by asking us to communicate better, imagine more boldly, and innovate more responsibly. Today's speakers exemplify that beautifully. So today, we will be exploring creativity and systems thinking with Dr. Kenneth Vaden, our first speaker, and his presentation, Creative Emergence, STEM, Curiosity, and Algorithmic Art. Dr. Vaden will be examining how algorithmic art mirrors scientific experimentation, how simple rules generate complex systems. His work shows that curiosity-driven system design underlies both scientific discovery and generative art. Next, we will welcome Embry-Riddle alumnus and best-selling science fiction author, Josh Dalzell, who will be presenting The Art of Possibility, where science meets storytelling. Joshua demonstrates how rigorous scientific training, which he received through Embry-Riddle Worldwide as both a bachelor's and master's degree alumnus, fuels imaginative fiction and how storytelling, in turn, inspires engineers and explorers. He reminds us that the future is built in imagination before it is built in the lab. Later in the morning, we will turn to the cosmos by talking with Dr. Frank Summers, an outreach physicist at the Space Telescope Science Institute. Dr. Summers combines research simulations and cinematic rendering to make the universe both scientifically accurate and visually breathtaking. His work on the Hubble Space Telescope, the James Webb Space Telescope, and work within IMAX films shows how visualization shapes public understanding of space. In the afternoon, we will shift into the public space and civic art with Pranisha Reed from the Atlanta Airport Art Program. She'll discuss how one of the largest airport art programs in the country integrates art into infrastructure, shaping the daily experience of millions of travelers. This is Humanistic STEM embedded into lived environments. We'll also speak with Andrew Carruthers. Andrew Carruthers is a master violin maker who pushes beyond traditional forms. Carruthers fuses acoustical inquiry with artistic innovation, reminding us that engineering and artistry have always coexisted. If you happen to catch the Super Bowl pre-game performances and saw some of the stringed instruments that were backing up the singers before the Super Bowl, those were the instruments created by Andrew Carruthers. Finally, we'll take a look at the MiG-21 Project documentary. The MiG-21 is a 5-year multidisciplinary effort that transforms a Cold War fighter jet into a monumental work of art, turning an object of violence into a symbol of resilience and collaboration. And we'll conclude our day with a conversation with Cody Oswit, who is the exhibits developer at the Museum of Flight, who developed the exhibit which showcased the MiG-21 at the Museum of Flight in Seattle. So he'll talk about the challenges of creating an exhibit like that and what's coming up at the Museum of Flight. So we're about ready to introduce our first speaker. So Dr. Kenneth Vaden. Dr. Kenneth Vaden is an assistant professor of otolaryngology at the Medical University of South Carolina, where he uses brain imaging and biostatistics methods to study age-related hearing loss and listening difficulties. Alongside his academic work, he creates generative art using custom-written code in the R programming language. His algorithmic artworks use geometry and simple rules to generate complex visual systems, blending scientific thinking with an emergent creative practice. All right, Dr. Vaden, we'll let you take it away.
Thanks, Christy, and thanks, Alexander, for a really excellent introduction about humanistic STEM. I'm going to go ahead and share my PowerPoint here. Here we go. And just confirming really quick, that's the PowerPoint, not the presenter view. Okay. Thank you very much for a great introduction. This is a talk that I'm really excited to give, and I really appreciate being invited to present today. The title of my talk is Creative Emergence, STEM, Curiosity, and Algorithmic Art. And I'm Kenny Vaden, an assistant professor, a research faculty at Medical University of South Carolina. Let's see. There we go. So for the overview, I'll be discussing foundations in science, kind of a little bit of background about myself and my interests and how that led me into generative art and algorithm-based art. I'll be discussing kind of a conceptual framework about curiosity, systems thinking, and emergence, and how those play a role in science and how that, again, bridges into art. Throughout the talk and towards the end, I'll be highlighting algorithmic art by artists whose work I love. And of course, there's not enough time to talk about everyone, but I wanted to highlight some of my favorites. And then I'll discuss some shared creative processes between art and science, and then discuss implications for STEM. And then I don't know, I'm not sure if we're going to be asking questions throughout the talk, but if we're asking questions, I'm happy to answer them as I go or after the talk. So we'll start with this this plot. So this was something where I was a figure a long time ago that I was working on, where I was mapping significant age-related effects on a white matter tract that we had mapped with diffusion tensor imaging from the brain. And this is the inferior frontal occipital fasciculus. So it's also called the IFOF. And I was inspired by some really amazing MATLAB plots that some of our collaborators on the West Coast had developed. And I wanted to see what I could do in the R statistics language. And this was kind of a foundational plot because I had to figure out how to plot the little segments of each tract in the correct order. I started playing around with shading and light, and eventually added the actual significant effects that I was trying to see on the structure. So this is the inferior frontal occipital fasciculus here. And we can see sort of I guess my mouse isn't going to work, but on the left side, you can see the anterior end, and on the right side, you can see the posterior end. And so this is what I normally kind of give my talks on, this thing that I have my PhD in. But making this plot inspired me, and it really made me wonder if I could use the same scientific tools that I use for science to make art. And so to give you a little bit more about my research background, some of the best advice I ever got was be able to program your lunchbox. It basically means that you have to be able to program a lot when you're working on your postgraduate work, and that proved to be true. My postdoctoral work and research since has really been focused on age-related hearing difficulties, listening difficulties, and hearing loss, and trying to kind of break down the different types of hearing loss that older adults commonly experience. I also studied the brain systems that support task engagement and challenging listening conditions, and so that IFOF is part of a larger set of systems that seem to be affected by age. So there was lots of coding, lots of statistics, and many, many plots. And to the left, you can see this was kind of my first attempt to take some of the lessons that I had learned from plotting those white matter tracts and using it to make art. And what I was doing was a random walk in 3 dimensions, and then plotting all of the segments from the farthest away to the closest. And this was just kind of an interesting bridge for me because it was purely creative. It didn't have any real data in it, but it was using a lot of the conceptual tools that I had developed in pursuit of a beautiful plot for publication. Between science and art, there's a lot of cross-talk between the approaches. We go through a process of exploration and iteration in science, and this is especially true with art. There's discoveries along the way, replication in new data sets or in new forms, and documentation. And I think, especially as an algorithmic artist, it's really important to come up with ways to explain to a lay audience what you're doing. Like, how does this algorithm work, and what are what your goals were when you were trying to code something. And so a lot of this came out of a sort of pandemic art practice. And so this plot was kind of a seed that grew into a body of artwork as I worked on daily artworks from the confinement of my house. So there's some big conceptual ideas outside of things like keeping a lab notebook or maintaining old code. There are, I think, bigger conceptual parallels between scientific and artistic creative pursuits. And so the big ideas for the talk today are curiosity, systems thinking, and emergence. And in curiosity, like, obviously we're exploring unknown possibilities. So as I was working on generative art, the process involves editing your code, viewing the results, editing your code some more, viewing the results again. And the video to the left is showing that process. So it's a couple minutes long, and it's showing hundreds of frames where I was going through and, well, what if I changed this, or what if I tweaked that? You don't get that with biostatistics or with data analyses where you're cleaning up the data and you're figuring out what's broken in your code. But I think that this kind of reflects that type of iterative process where you explore and you learn things about the data and learn things about the code. And so in art, I asked myself a lot, how could I make that? How could I do this? And in science, you also ask that question quite a lot. And it involves a process of experimentation and problem solving and iteration, just looking at failures and trying to improve the results over and over. To the left, this was an attempt to do code in 5 minutes, and it ended up being hours of time. And I never really liked the final result with that one. But again, it just kind of highlights the process that we go through as artists. So anyway, innovation comes from bringing outside ideas to old problems. And I think this kind of coding that I've done for many, many years and learning to control the plot area and the dots per inch and the size of the font and everything for publications led me to have pretty exquisite control over the plot region. And so I was able to bring a lot of the tools I had developed and the skills and techniques from science into art. Likewise, I feel like at this point, whenever I make a new plot in science, a lot of what I've learned from art informs that. And so I think that creative process can kind of feed sort of two interests and help you learn things in each domain. It's very important that your approach shapes the solutions that you may consider to a problem. And so, again, like, because I used art statistics language, that shaped the types of artwork and the types of plots and even the types of prints that I would eventually make. And likewise, people who brought a different background, whether it's Python or P5JS, or an engineering background versus a biostatistics background, that all of these different approaches sort of shape the art that you see. And so that is something that we'll see a little bit with the different generative artists that I highlight today. But it basically creates we basically are in the process of like creating a framework for structured exploration. So you take the tools that are familiar to you that you've kind of mastered, and then you start applying them to something totally different. So to the left is another example of curiosity driving experimentation, although I don't go through the entire process there. But my question here was, how could I use a random number matrix to control isometric columns? And so I like squares and I like waves, and so I wanted to figure out a nice way to basically control the layout here and make isometric columns that created kind of an undulating surface. And the long and short of it is I figured out a Gaussian smoothed random number matrix would do the trick. But this is a really specific instance of taking tools that I'd regularly used in science, where we want to maybe smooth high frequency noise out of the data, so we can focus on larger trends, and that could carry over to art. So a lot of times we see in science and art that you begin with curiosity and exploration. Now, this is work by another artist who goes by Finga Code. It's Junior Ngoma. He's from Cameroon and lives in London. And this was his description. This is a color and motion experiment exploring how movement and colors affect moods. And he titled it Rorschach. And so, he uses a different tool set than me. He's using software called Touch Designer, but he definitely has a lot of code art in his toolkit. And this was, like I said, another really cool experiment, and it was an artistic experiment. Another really big experimenter in the artistic domain is Neil Shivdasani. He's from Atlanta, Georgia, and does these just fabulous works. And on the left, you can kind of see the progression of his work over the years. And on the right was kind of a really cool experimental piece. I don't have a video of this, but he has a grate that you view the artwork through, that sort of dark square. And as you drag the grating along, it animates the artwork, even though the artwork is stationary. And so I think he's using some really cool visual effects there. But yeah, he's really well-known experimentalist, and he does artwork with concrete and all kinds of cool materials. So I wanted to highlight his work. This is the part of the talk where everybody can kind of cross their eyes a little bit if you want. This is a stereogram generative art that I made. So when you kind of cross your eyes slightly, you can cause these two images to fuse binocularly. And this is where I kind of wish I could see everyone's faces to see if anyone is doing this. But at any rate, this is a fun experiment that I did. And I was curious whether I could get the visual separation of the two structures just right to recreate depth. And I was able to do it. So again, this is just an example of curiosity is the engine of discovery. Jens Klarholm is another artist who he has a background in engineering, and it shows in his work. He does these really amazing homemade robots that he uses for creating these beautiful plots, like the one that's shown in this video. I will say, like, as a disclaimer or spoiler alert, that this video does not show robotic paper destruction. A lot of his videos do. He traumatizes the paper sometimes. But through a prolonged process of trial and error and persistence, he produces these beautiful results with his artwork. He's based out of Sweden. And yeah, engineering code artist. And again, like he spends time not just designing the systems, but 3D components to hold the pens, exhaustively experiments with ink sets and paper, and has done work with various media, including just purely digital artwork, and also different sunlight exposure techniques to the art. So again, Jens and I have gone back many years online, and yeah, he's a really cool tinkerer, I would say. I've done a little bit of work myself with robotic pen plotter that I did not build, but basically this is a nice way to kind of see how, again, you can experiment in physical media, not just digital. And so I'm sure there's some people in the audience who are working with robotics, and this is something you can consider, is making a complete mess and saturating your paper with paint and exploring that process. And in the end, through like a lot of trial and error, like, you can slowly discover techniques that will work. So we can see here that the code that I wrote basically created a series of parallel tracks. And then I even set up points based on measuring how far the wet paint would drag to sort of dot the paper, and then the pen would get dragged through these parallel paths and create these really beautiful lines. And so moving on from curiosity to systems thinking, systems thinking is really thinking like a type of framework where you think about components, processes, relationships, and rules. And so we're kind of moving beyond experimentation and thinking about systems. And part of the reason that I used this artwork to highlight systems is that this artwork was using a series of circles that were descending from the top of the screen, and they weren't allowed to overlap with each other much. And then the lines are sort of settling on top of them, like sedimentation processes in geology. And so, systems thinking involves understanding how relationships between components produce behavior. On the left, you can see that these circles are basically undulating with like a nice periodicity to them, where they kind of expand and shrink over time using a sinusoidal function, which is like a really nice way to create kind of a looping, an infinitely looping artwork if you're doing animated artwork. In science, like, we think of systems as cells, tissues, systems, organisms. Another example is like in terms of an hierarchy, or neurons, layers, circuits, and ultimately behaviors from organisms. So, so these are, we can apply the same sort of thinking in art with shapes, rules, randomness, as well as iterations and transformations on the visual elements in the piece. So this is by Amy Goodchild, a London-based artist, and you can see here that she's using a flow field to basically control the pathways of these lit up paths, and they're just really beautiful. Another, I thought, example of artwork that kind of falls into systems thinking was Matter Waves by Amy Goodchild, and you can see like she's exploring the idea here of light as particles and waves, and so you can see this kind of really nice flow between the two states of particles and fields, and just wonderful color choices. This is another artwork in that series that she did, Matter Waves. And then finally, this is kind of this is an animation that I did involving a lot of individual little pieces that operate within a system. And it works by, I'll rotate it, I'll get it rotating again. You can see that each of these little elements are moving around, and then it's a little less obvious that they start over at the bottom again. When the wave moves from the back of the screen to the front of the screen, it's the same elements, so it looks kind of like you're moving through a tunnel. And then the colors are basically gradually shifting and determined by the location within the wave. And so there's kind of a lot of things going on in this piece. And then on top of it, I was using music to determine the undulation of the base of the wave. And this was kind of a nice example. It would have been a nice example of kind of exploration and experimentation, but it was a little too photosensitive in terms of the flashing lights when I was working on this in the early days of this animation. But yeah, so this uses a lot of systems to kind of organize all of the little pieces so that they all work together. And then sort of the final big concept that I wanted to discuss today is emergence. And emergence is a key concept in generative art where complexities arise from simple rules for interactions. Emergence describes how unpredictable and complex outcomes arise from simple rules. So again, this is kind of, building onto the preceding concept of systems-based thinking. And there are examples in science of ant colonies where the individual behavior of ants makes the collective behavior of the anthill a little less predictable, in the sense that the ants collectively are accomplishing what we might think of as almost like a single organism's tasks, right? So instead of dividing all of the functions of cells and tissues and systems into, one organism, the colony of ants kind of operates as a single whole. The same can be true for birds flocking and murmuration, where birds form these complex patterns by just trying not to crash into one another and having a few simple rules about which way they're going to go. And they can create these just hypnotic waves of movement that confuse predators or maybe even scare predators away. And finally, like brain systems, we can think about the complexities of human thought arising from neurons and neural circuits. They're fairly simple units, and yet they're accomplishing so much. And so, and I guess like the last thing that I was thinking about outside of collective behavior is that the scientific process itself generates unanticipated discoveries. A lot of times we have a goal in mind, we're executing on that particular goal, and we're interested in this particular question, and we see something curious, or we do something a little funky with our analysis and then see something we didn't expect, and then we go back and it's real. And so I do think like you read about these types of things all the time in terms of the scientific process, and there are a lot of surprises and pleasant surprises, I think, sometimes in science, and just as a result of kind of being persistent and working at it. In artwork, we see examples of complex outcomes in the sense of flow fields or rules. Here I'm I have stacking dishes, these little circles that are getting, undulating in size and shifting randomly across space, but they form these kind of neat little columns with just a couple of simple rules. And the effect of the whole piece is much bigger than, one or two little circles moving around randomly. And so I think like, in art, we see these common fates and collective behavior and Gestalt principles that kind of organize visual perception in a way that the effect of a artwork can be a lot bigger than what you expected when you were working on it in the first place, but also what you would anticipate based on the elements and the rules that you have. This is an example of emergence that is from Eric Calderon. He did an artwork called Chromie Squiggle, and this is an example of a single Chromie squiggle in the sort of upper left. And the reason that I chose this as an example of emergence is that it shows the algorithm. Like this artwork, when you see all of the artwork together, you can see all of the possible variations that this algorithm could produce. This really simple algorithm where you're shifting across a set of sort of neon colors and you have a wave that kind of randomly is perturbed, but it's smooth. And, in some cases there are outlines, in other cases there are empty circles or blurry circles. Small or big circles, but there's not, on the basis of just a few different properties, he was able to generate about 10,000 of these. And you can view all of them on a single web page, which is pretty amazing. And this is artwork by Itzel Yards, or IX Shells. She created this artwork called Interlinked, and this was an homage to women in art. I did not include the music, which was like really beautiful music as well, but it's just a little loud, or I was worried about the volume. But you can see here, she's using flow fields to basically control the drift of little visual elements that are all linked together. And it just, to me, like this really captures well the idea of emergence, because individually, all of these elements have very simple behavior, and they themselves are very simple. They're squares, they're little lines, there's some shading involved. But all together, the effect of the artwork is that it comes to life. It looks like it's alive and moving, and so it has kind of an intuitive or an instinctive element that she's managed to really bring out with her artwork in beautiful ways. This is artwork by A. Mashiro from Tokyo, and I was able to get a quote from him regarding art and science. And so what he said was, what I find fascinating is the unexpected output, the uncontrolled parts. In science, it leads to new discoveries. In code art, it becomes beauty and individuality. And Mashiro uses balance and color in his artwork to try to, these simple visual elements to try to create kind of balanced works. And so in this collaboration with Yiwen Lin, they created this really beautifully balanced outputs. And I should note, each one of these rectangles is a single output from the algorithm. And so again, you can kind of see how the sum is greater than the whole of its parts, in kind of a Gestalt sense. This is artwork entitled Jazz by an artist who goes by Fingacode, Junior Ngoma. He's a London-based artist, and he gave me a quote about science and art, and he says, "My process begins with code as a sketchbook, where I explore simple rules and let repetition, randomness, and constraint shape the outcome. I'm interested in the space between control and emergence, building systems that feel alive, where the final form is discovered rather than fully predetermined. Each piece becomes a record of that dialogue between intention and autonomy." And I do think, like, generative art and algorithm-based art, prior to AI, really emphasized autonomy, like the idea that you're building a machine that will create art independently of you. And so I think he's of that kind of classical tradition here. Here's some artwork by Mood Soup. These are different iterations, I think, as he was working on concepts for his art, shown on the right. And I have a quote from him as well. Which laws or conventions or deviations shape our world? How does complexity emerge from a basic set of rules? And how can these laws, whether hidden or apparent, be represented visually? Through generative art, these inquiries take shape as innovative concepts, ideas, shapes, colors, and patterns in a new aesthetic. The creation of generative art is always the result of a process of exploration, refinement, filtering, and optimization. Sometimes serendipity takes over in the course of the process. That's where magical moments, unexpected discoveries, and happy accidents arrive. So that's Mood Soup, and he's a Belgian artist, and so, you know, happy accidents as an idea that he brings up really briefly in his quote. And, you know, this is a parallel, I think, in art and science, that happy accidents are more common and or often occur in coding. And they, you know, a lot of times if you have an accident in science, it's an oops and an experiment is wasted, or, you know, data or not showing what you were hoping. But sometimes we have these happy accidents, and the artwork that I'm showing above here is where I had a oops with my code, where I was trying to play around with circles, and they started to form these really interesting patterns that reminded me of the screens that you see on television from the 50s when programs were pulled. So both art and science sometimes involve an element of luck and outcomes that exceed expectations. And then this is the random number generator in you know, the slide about random number generation. We use the random number generator to both generate randomness, but also to control the state of randomness in both art and science. I mean, for science, and I'm sure this is the case with engineering, if you introduce stochastic elements, in particular statistic tests, we want to make sure that the results are perfectly replicable. And so you seed the random number generator. And so when we do these long form artworks, similarly, we use a random number generator to produce unexpected and random looking outputs, but we also want to make sure that we can freeze the artwork in a particular state. So that's kind of a nice parallel between those. Finally, I wanted to kind of highlight the importance of roles and community in both art and science, mentors and community. On the left, I see Forrest Young. He taught me stats and programming, and emphasized visualization, which I think is really important. And then, you know, there's a crew of stained glass artists that I worked with in the summer. I'm the guy in the back with long hair. On the right, we've got some people discussing artwork at art blocks. But you can basically, and, you know, a gallery with my art in it, which was fun, and meeting other artists. And so I do think like that community in science and art both really help you learn about, you know, how to be a better artist, or how to be a better scientist, and what's interesting right now to people, and what do people think. And so I think like it's really, those relationships kind of shape your work as well. Okay, so in terms of implications for science and art, algorithmic art has technological roots that reach to the start of modern computing machines, and as a result, like this art type of art shares important features with science, probably more so than other types of art. But it you know, includes creativity, systems-based thinking, and emergence, which are sort of big concepts, I think, here in common to both. I think scientists and engineers can benefit from engaging with artistic processes because creativity drives innovation and discovery. And finally, I wanted to thank Christy Reynolds and the HSTEM organizers for the kind invitation to speak today. I wanted to thank the artists who gave me quotes and permission to include their art, including Jens, Clara Holm, Amy Goodchild, IX Shells, Finger Code, Neil Shivdasani, Amashiro, Mood Soup, and Snowfro. And I'd like to thank everyone for their attention.
Thank you so much. That was amazing. Do we have any questions from the audience? We do have a microphone if anybody would like to ask any questions. Yes.
Thank you. Thanks so much, Dr. Vaden. Are you able to hear me?
Yep.
Awesome, thanks. That was a great presentation. Really appreciate it. So algorithmic art is a very hot topic right now. And while watching your presentation, I was really struck by the difference between you do, which is like using algorithms to make visualizations of like data based on things in the world, right? Versus, the kind of generative AI art, which is more like meta artistic in the sense that it's like, here's an algorithm that has analyzed art to try to make art, rather than an algorithm based on data, right, from something in the world, like a brain, something in the brain or something in the cosmos to create art. So I guess I was curious what your thoughts are about the difference between these types of algorithmic art, right? Like, I don't want to ask like the question is like, is Gen AI art really art? But it seems like there's a really qualitative difference between these two kinds of processes. So I guess I just wanted to ask your thoughts about that.
Yeah. I think in the generative art, traditional generative art community, there was a lot of excitement and interest in AI art at first. And I think it kind of, I wouldn't say that it's peaked. Like, I think that there are people who figured out clever ways to incorporate AI into their artwork. And I anticipate that future generations may not have to master code through 15 years of research experience in the way that I did. They may be able to ask AI, like, how do I, make a circle, and not have to really like hammer it out that way. So I do think that AI will play a role. I think that to some degree, it's kind of up to an artist to decide like what tools to use. And how to use them. I think in my practice, like, I find traditionally hammering it out relaxing. That's what I like to do at the end of the day. I don't really want to ask AI how to do things. But occasionally, like, I'm scratching my head, can't remember a function name or a package name, and I'll ask. I'll just, what is the name of the function that contains the Gaussian smoothing function that I'm trying to use? Okay, cool. It's fat stats. So I do think like there is a role for AI. I will say, like, the artwork that I do generally does not use data in it. Like, I really like to use a random number generator to really like drive the variation. But occasionally, like, there is art that I've done that like used my own brain image, for example. But I'm trying to think, does that answer your question? I feel like there was something else about AI in there, but.
Yeah, no, that's great. I appreciate your
Okay.
comments. Thank you.
Yeah, thank you.
All right. Any other questions from the audience? I had one question. Do you ever find that the coding you do for your artwork then feeds into your scientific research coding? Have you mastered any techniques that then you're like, oh yeah, I could totally apply this to the research project I'm working on?
Absolutely. Yeah, there are definitely instances like learning how to blend colors, like with I'm trying to remember if this was a hand. I think I hammered out a function to blend colors at one point, although I think there are some that exist in the world. Other things that would include like figuring out how to orient shapes. So flow fields are I mentioned them kind of obliquely and didn't really get into how they work. But a lot of times what we're doing is using some sort of information to determine the angle of different visual elements. And so in my own work, like a really clean example that comes to mind is a plot where I was showing the trajectory of hearing loss along a couple of different axes and rotating these little triangles or pointers to show like how people's hearing loss would change. If they were here with their hearing loss, where would they be in 10 years or 20 years? And so being able to show kind of the full field of measurements and where everyone went at once was like I felt like that was a artistic / scientific achievement for me.
Oh, that's great. Hey.
Yeah.
If there are no other questions, I think we can let you go. Thank you so much for your time. That was fascinating. That was a wonderful way to start off our morning.
Happy to be here today. Thank you so much for inviting me. And I hope it inspires some people to try their hands with creative pursuits. I mean, it doesn't have to be code art, but it's really fun to kind of exercise those parts of your brain. And code art is just one way to do it. Thank you.
Thank you so much. Hello, we're about ready to get started again after our break, so we'll be picking up with Joshua Dalzell. Joshua Dalzell is a US Today best-selling science fiction author and Embry-Riddle Aeronautical University alumnus whose work blends technical insight with imaginative storytelling. After earning his Bachelor of Science in Professional Aeronautics and a Master's in Aeronautics Science through Embry-Riddle's Worldwide campus, he built a career grounded in aviation and aerospace, including service as an avionics technician in the U.S. Air Force and work in the aerospace industry. Dalzell's deep knowledge of engineering and flight informs his acclaimed Omega Force and Black Fleet series, where spacefaring crews and interstellar conflicts come alive with scientific realism and gripping adventure. So we will switch it over to Joshua Dalzell.
All right. How's everybody doing this morning? Thanks for having me. Thank you to Dr. Reynolds for the invite to speak this morning. Today I want to talk to you about where science meets storytelling and why these two are not mutually exclusive, why they can coexist together. There's going to be some overlap between this presentation and the last one and the general concepts of how creativity can inform the technical world and vice versa. So who I am. My name is Joshua Dalzell. I enlisted in the Air Force right out of high school. Worked on B-1Bs as an avionics technician. Been pretty obsessive with flight and airplanes and rockets since I was a little kid. Worked at Lockheed Martin for a few years after I got out of the Air Force. Transitioned over to L3 Communications with the space vehicle avionics section and worked on test systems there. Probably, and during that whole time, there had been the thread of wanting to be a writer. Lots of query letters to agents, blind submissions to publishers, and nothing ever really got traction for me. And so I just sort of kept it, in the drawer as a hobby. And then I guess it was about 2012, I discovered independent publishing. And so I figured, well, this is my last chance to see if I just have any traction at all in this. So I cleaned up one of my old manuscripts, got it publishable, put it on Amazon, and it took off. So by 2013, I was having enough success that I was pretty excited about this. I thought this was going to be a good hobby that was a income booster. And then by 2014, I'd actually started earning enough income that I had to kind of make a decision if I wanted to do one or the other, but both were suffering because of the time crunch. So I went full-time writing. A lot of people thought I was absolutely insane. At the time I was on track, I was wanting to go into program management and had been wanting to work on the Delta IV Heavy program. And then kind of in their minds, I threw it all away to be a writer. And a lot of people didn't understand it. And but since then it's, I've had a few million sales, had Hollywood's come knocking. I've had best-selling books, 12 or 13. And the point of that is that sometimes you have to be willing to take the risk. And a lot of us, especially technical-minded people, are very risk-averse or analytical in this. So just do the math on what your time is worth, what you can earn, and what your obligations are. And sometimes it's worth it. Sometimes it doesn't work out. But thankfully, I was able to parlay this into a full-time job. But even if it just stays a hobby and it's supplemental income, there's a lot to be said for that. So a lot of people see these as two separate worlds. And to be fair, I'm going to be talking about storytelling through the lens of science fiction because that's what I do. I think that's the most direct connection to what we do at Embry-Riddle. So one side is it just tyrannically adheres to calculation, empirical data. The other is allowed to run wild and sometimes to its detriment. A lot of bad science fiction out there that's not grounded in reality. And science fiction readers are savvy and they can tell who has done the research and who has a background, who doesn't. What I have discovered is that there's a vast readership that wants both these things. They want them to coexist together. A lot of engineers read and they want to read something that somebody's put the time in and done a good job with it. Hard science and scientific discovery will fuel people's imaginations and storytelling. Famously, Edgar Rice Burroughs' Barzoom trilogy was based on the theory that there were canals on Mars. That was made popular by a guy named Percival Lowell, who speculated that the lines on Mars were canals and evidence of an advanced culture. The theory ended up being bunk, but the point is that the discovery of that sparked somebody's imagination and led to a series of books that is now considered, essential reading and a modern classic. And there's an inverse relationship to this as too, which is more in line with what I want to talk about, which is your storytelling can inspire science and innovation. Many notable examples. Cell phones were from Star Trek communicators, tablet devices, AI, submarines were inspired by Jules Verne's internet credit card. A lot of these cases, technologies we consider mundane today have now even surpassed the wildest imaginations of writers from even 20 years ago. And a lot of these were engineers and scientists who were driven to research. They wanted to see the world that they had read about, and they forced it into reality. And that's sort of the power that a writer can have over society in that way. So the case study is my book Warship, which was published in 2015. This was an attempt to write. So prior to this series, I had written a series called Megaforce, very campy, very light science, a lot of I guess you would call it space magic, but it was not meant to be a serious. It was lighthearted. It was an adventure. This was an attempt to write something gritty and grounded, and something that the technology is underpinned by what we know could be possible today. The engines in the ships are derived from the Vassimer engines developed by Ad Astra. Even the faster than light travel was adapted from Miguel Alcubierre's warp drive. Real orbital mechanics, time distance calculations. There's all this stuff that I learned at Embry-Riddle. I needed to make this book as realistic as I could possibly do it. And this was the first time I really had a real good merging of these two, where the had to be compelling with characters and a story that people wanted to read about, but also the science and the math had to be close enough and accurate to be believable, or the whole thing would kind of fall apart. The result was this book was released in January 2015, and it went deep in the top 100 overall of Amazon. And this was a time when most science fiction wasn't, maybe in the top 500s, 400s. And it stayed there for a while. It was a 2015 Goodreads Choice nominee for Science Fiction Book of the Year. It's been optioned recently for a movie from Rick Eisner's group, who did The Expanse. And so the big thing about this book compared to the other ones I wrote, that people were really taken by the realism of the science. They liked that. And if you can really weave that into a compelling narrative, you will suck people into your world, even if they don't fully understand it. There's a competency that kind of comes through your writing that they'll respond to. This kind of captures the core of what I want people to take away. And bearing in mind that when I say storytelling, I am talking specifically about science fiction, but there is crossover if you write thrillers and especially crime thrillers, things like that. There's a sweet spot between these two where they coexist, and they can make each other stronger. You're not just building realistic machines and worlds, you're building a world that you want to suck your readers into. And so having both of these skill sets working in tandem with each other, it will really take a good story and make it a great story, whereas bad science will take a good story and make it an unreadable story. And people also respond to that. Just my other series, like I said, the Megaforce stuff is very Star Warsy in its approach to science, and there's a large base that doesn't like that. They want things defined, and they want it to be realistic. And this sort of leads me to this. Visualize the relationship as an infinite feedback loop. Real science and engineering create the foundations. The dreamers and the storytellers take that and use it to inspire the next generation. And the cycle continues, and progress marches on and on and on. All these things will all kind of exist in this infinite loop together. We don't have to separate the science from the art, and I think sometimes we do that as a disservice to both. Where in reality they coexist very well. So why write besides the money and the leisurely lifestyle? exercising your creative muscles will sharpen your problem solving skills. It bolsters communication skills, the ability to convey complex ideas. Whether you write as a hobby or have dreams of making financial success, or simply you're just an avid reader, and there's a lot to learn and strengthen and add to your skills developing now that you can use in the technical arena and vice versa. If you do have aspirations of being a writer, being strong in these technical fields will strengthen that. They're complementary skill sets. They're not adversarial or even disassociated. So if it seems like I'm really hammering on this point, where it's redundant, I am. It's important to design and build things that competently fill a need. That's what engineering is there's a need, you design something to accomplish a task, to do a function. But there's also something beautiful about making things that serve no practical purpose whatsoever other than to satisfy the human need to explore. A lot of what we do, especially in space exploration, manned or unmanned, doesn't have a ton of practical application for us here on Earth, but it's about inspiring us as a species to move further, to reach further. It's something that's unique to us. Storytelling is something that lets you leave an imprint on the people who are going to come after you. It could outlive you. It could be something that, a book could be read by thousands of people, and they're just that one person that will be the one that designs. There'll be a breakthrough in a technology, and they did that because they read one of your stories, and that's you can indirectly shape the future whether you'll ever know it or not, and that's there's something very, very satisfying about that, even if you're not necessarily not about taking credit for anything, but it's about knowing that you contributed. There's nothing wrong from living in both worlds. Nothing keeping you there. There's the left brain, right brain fallacy. That was who was the guy? Roger Sperry was the scientist that kind of coined that, and we use it now as kind of an idiom. But before, there was people really thought that you were either left brain or right brain dominant, and those two halves were either analytical or creative. And what we find is that the brain works together to do both functions. These aren't separate aspects of our personality. They're things that either are nurtured or suppressed, or that we have aptitudes for. If you find you're interested in trying to write, you probably have an aptitude for it. If you find you're a voracious reader, you probably have an interest in it. I would encourage everybody, just as a mental exercise, short stories, anything that you could pin down, to just exercise and really work that muscle, and you'd be surprised maybe what is lurking in there, and maybe the kernel of an idea that you can nurture and develop into a full-blown narrative. I have a deep love and passion for both engineering and creative endeavors. I'd be perfectly happy doing either. There's things I like about both. On the writing side, the pay's better, and I like the leisurely lifestyle. I don't have an alarm clock. I kind of do what I want when I want. But I really do miss the side of even the dreaded meetings. I miss being part of a team and problem solving, and the technical aspect of building something that has to fill a function in a larger part. And that's something that I really don't have anymore. So you will find that you miss one or the other. This was the path I picked, and maybe going back, if you could find a better balance of being both an engineer or a pilot and just writing on the time. There's some Embry-Riddle writers that are airline pilots that also write novels and publish them, and that's they find a nice balance in that. So you're building the tools now to do whatever you want, even if you find that it's not originally what you thought you were going to do. What I learned at Embry-Riddle served me both as an engineer and as a writer. So if you take anything away from this, I hope it's that even though you're pursuing a STEM degree and likely a technical career, or as a pilot or engineer, don't look at your humanities classes as something you just need to get through to get the degree. There's a lot to be pulled away there to both bolster your technical prowess, but you may find something in there that you really, really are drawn to, and it may take you in a direction you didn't expect. So this is missing a couple of slides, so I think I've run through a little faster than I would have liked. I can go back and touch on any other points anybody wants to talk about, or any questions, and anybody have anything?
We can see, yes, we have a question from the audience. So we have a microphone here. We have some questions.
Hi, thank you so much. I know you can you see me?
I can see the podium.
Disembodied voice. Okay, cool. Thank you. As a professor of humanities at Embry-Riddle, it's so nice to hear you say that the students don't have to just begrudgingly get through my classes. So I'm curious, I have lots of questions for you, and congratulations on your career. But during your Embry-Riddle coursework, or even your coursework, I saw that in Cincinnati you got your associate's degree. Was there a humanities or literature class that stood out to you that was like, this is working, and I know you've always liked writing, but is there one course that stood out to you, a literature course in any of your degree programs?
There was, I took a creative writing course, and the instructor, and I apologize, I cannot remember her name, but was absolutely excellent, and did a great job of finding a way to kind of draw me in and break down, larger narratives and how you construct these. Because, you start to, I think I was ever trying to write a novel. The very first time you do it, it's like, it's like a presentation. You ran through, it's like, well, that should have gone longer, and I'm not sure why it's so short. So trying to get something out to an 80,000 word narrative is tricky. And she was able to, through this class, break down the act structure and then how this looks on, it's like, okay, now, like, basically engineering a full length narrative. And then the other classes that really, really helped in character development, I took psychology classes too, and they were really fundamental in how I was able to build characters that were much less, cardboard cutout. They were very three-dimensional, and without being, cliche or caricatures.
Thank you so much. I'm going to reach out to you and request that you make me like a little video to kind of amp up our gen ed courses, and then maybe I can slide you into my American literature class that I teach for Worldwide, and we do it through a humanistic STEM lens. So thank you so much.
Thank you.
Thank you so much for your presentation. I am a PhD student at Embry-Riddle, and I, of course, love science fiction as much as I love my STEM courses and my research. I want to know, as an author, what are some recommendations for books that you have, of course, other than your own books, and perhaps, like, what are you reading right now?
Actually, I still got some of my textbooks, and there's a shelf. I mean, there's Understanding Space was a book that I took orbital mechanics, and that I still reference now because it has a lot of good information when you're trying to just, even if you're not going to put the math and the technical details in the story, you need to get just your time frame. So you need to know a ship has to move to this transfer orbit to move. It's going to take this long to get this far out under this acceleration, and those calculations are all kind of available there that I can go through and fill those in now. And what's nice about that is that I can do it kind of quickly. I tried to use AI for a little bit on that, and it's been very good at giving me wrong information very confidently. And so I've just gone back to doing the calculation myself. Right now, I am reading a book called The Premonition Code, and then there's another one called Time Loops, because I'm working on a new series where there's a group of people have a genetic anomaly where they perceive time a little differently than the linear fashion that humans do, and they get little quick glimpses of probabilities a split second in the future, and that's kind of what the story revolves around. So now I'm kind of brushing up on all that.
You said that first one was Permission Code?
The Premonition Code.
Premonition Code. Okay, perfect. I'm writing this all down. Thank you.
Any other questions from the audience? I was wondering, as an author, do you ever feel like you have to dial back on the technical or the scientific content that you put into your writing? It could be tempting to go into a lot of the physics of the engineering. Do you ever have to find yourself kind of editing yourself a bit?
Absolutely. And that is a natural tendency of when you have a pocket of knowledge that you're good at and it's time for it to shine. It's like, you are going to learn something today, everybody. Like, it's time for me to tell you about this. And then and I'll put it in there, and then I goes to the editor, and he's like, you probably need about half this pulled out, or really dumb it down. We don't need to know. And sometimes it can really be a little kitschy where you have your characters speaking to each other, doing the calculations just because you want everybody to know how hard you worked on that. Over the time, I have found a good balance in being technically proficient and correct in what I write, but not having the need to, show them exactly how I got there.
Excellent. It looks like maybe we have one question in the chat. What is your writing schedule or process like?
So in the morning, I get up and I break it up into 30-minute sprints. There's a screenwriter, his name's Thomas Donnelly. He wrote a couple, Sahara was one of the big ones he did and some of the Marvel stuff, but he has a really good process he calls it the downhill approach. So he writes for 30 minutes, and at the end of the 30 minutes, he just stops. And he stops in the middle of a sentence. And what he likens that to is if you have kind of an old junker car, you got to park it on a hill, and then so you can get it going forward again and roll to start it because it won't start otherwise. And having that sentence broken, you know exactly where you're going to go. So when you come back for your next writing sprint, you're already going downhill. You at least have one sentence and probably that paragraph in your mind of how that's going to go. So right now, my productivity at between 2,500 and 3,000 words a day, which is pretty good through the week. Once I'm down to editing and releasing, that will shift because I'll chew up more time doing revisions, things like that, and then marketing. But for the most part, it's about a 2.5-hour workday, so it's not bad.
How do you choose the cover art for your books?
Just whatever catches my eye. Worship in particular was something, even the title I was going for, I try to catch something that, like, I would imagine you're walking through an airport and would catch your eye. Simple title, simple cover. The Omega Force series with its two-pane design was actually, my cover artist came up with that. He gave 3 sort of concepts of the first one, and I liked that one, and then he just kept it throughout to keep it uniform. But usually I'll ask for what I've ended up doing is he's a good enough artist that I ask for the cover first or about a quarter of the way through once I know the title. And then I try to craft a scene around what he drew for the cover. So it's incorporated into the book.
Great. Looks like we have another comment in the chat. Oh. All right. Any other questions? All right. Thank you so much for joining us and sharing your time and expertise. We really appreciate it.
No, thank you, everybody. Thanks for the invite. I appreciate it.
We're about ready to get started again, so I'm going to introduce our next speaker, Dr. Frank Summers. Dr. Summers is an outreach astrophysicist at the Space Telescope Science Institute in Baltimore. For almost 2 decades, he has contributed to all aspects of the Hubble and James Webb Space Telescope press, education, and outreach through news media, websites, educational programs, social media, museums, and planetariums. His specialty is as an astrophysicist, creating accurate and aesthetic scientific visualizations by combining research simulations and Hollywood rendering techniques. His credits include writer, science advisor, and scientific visualization supervisor on the IMAX film Hubble 3D, and a science and script advisor on the IMAX film A Beautiful Planet. He contributed data, science, and visuals to the Academy Award-nominated IMAX film Cosmic Voyage, and directed the IMAX short film Hubble, Galaxies Across Space and Time. Please welcome Frank Summers.
Thank you very much. Glad to be here. Is my audio up proper?
Yes, you sound good. Thank you.
Great. Thank you. Well, welcome. I am very happy to be here. I had not known what HSTEM was before getting this invitation, and it looks like a wonderful program to go through. And I think that my presentation will fit in very nicely. So I'm going to talk to you about astrovisualization, and I call myself, as you heard, an astrophysicist, which is a combination of the astrophysicist part of me and the visualizations that we do. And I just want to tell you that I never intended for this career, okay? It's just sort of happened, going sideways things. So I just give it a little introduction to things because I call this the training of an accidental astrophysicist. So back in high school, this was when the Rubik's Cube first came out. And I, being a math geek, had to solve it. I was obsessed with it, and I solved it, and I created patterns on it, and I wrote a book about 30 different patterns on it. But you could also see me on the right-hand side doing the prince in the ballet Cinderella. I did ballet, tap, and jazz since I was 10 years old. All right. And so after high school, I naturally went to become an ice skater. I took 3 years off after high school to compete in ice dancing. And I was, at the height of my career, ranked 10th in the US in ice dancing. After that, I retired at the ripe old age of 21 and went to Virginia Tech to get my degree in physics. While at Virginia Tech, I also was a choreographer and director with Virginia Tech Dance Theater. After getting my undergraduate degree in physics, I went on to the University of California at Berkeley, where I got my PhD in astronomy. And simultaneously, I was in the University of California Ballroom Dancers, where I met my wife. That is a picture of me and my wife at a competition in San Jose. So what I want to emphasize here is that I have always had this deeply intellectual side of me. I'm a PhD geek and I've also had at the same time a strong artistic side to me, okay? And eventually I got the expression of that after doing, postdocs at Princeton and Columbia when I was hired by the American Museum of Natural History in New York. And Neil Tyson, Steve Soder, and I were the three curators that built this place, the Rose Center for Earth and Space, which opened in 2000. My work there taught me an incredible amount because I had to work extremely closely with the exhibit designers and really hone the craft of expressing complex topics to the public, which got me my job at the Space Telescope Science Institute in Baltimore, where, as you've heard, I've worked on Hubble, Webb, and the upcoming Roman Space Telescope that launches in probably September of this year. We're not exactly sure of the launch date, but it should launch this year. We'll have a new major space telescope up there. So, oops, hold on. I didn't mean to click that. So what does an astrophysicist do? It's easier if I just show you. This is a short film called Cosmic Wonders that includes 18 of the visualizations I've worked on over the years. Okay, so that was sort of our highlight reel that we created, and I guess you heard about these in the introduction, but a couple of the big highlights of my career is that I worked on Cosmic Voyage back in 1996, and this red stuff you see in the background is actually the simulations that I did for my PhD thesis while at Berkeley that were scaled up and up here in the film. So tongue in cheek, I get to say that my PhD thesis was nominated for an Academy Award. And then when I got to Space Telescope, I directed this short film that won the Best Short Film in 2004 from the Large Format Cinema Association, which is sort of like the Oscars, but if you limit it only to the large format film category. And as you heard, I got to work on IMAX Hubble 3D, which was incredibly amazing experience. And I also worked on a symphonic film with this composer, Eric Whittaker, Deep Field, The Impossible Magnitude of Our Universe. It was a blending of a symphony that he wrote inspired by the Deep Field with 18 minutes of visuals that mostly provided by us to provide a background for this amazing music. So I have been blessed to work on some really, really cool projects. And it's just kind of funky that an astrophysicist gets to do this kind of stuff. But you see what my background is, and it just seemed like it's a natural conclusion from where I came from. So what I really want to talk to you today about is one of our visualizations. I want to show you the details of how we create these and give you a feeling for how we combine science and cinema. So, the Pillars of Creation is Hubble's first really breakthrough image back in 1995. And I know that a lot of you in the audience weren't even born then, but this was a real watershed moment. It got the cover of Newsweek magazine and such. And it became an iconic image for the Hubble Space Telescope. So iconic that when we got better cameras and we had to take a new image of it in 2015. And so this is the image from 2015. You get the full feel of the pillars along with that sort of almost pedestal-like structure that it's sitting on, although that is not really a pedestal, okay? You'll find out in a second what's really there. Plus, at this point, we had a much better infrared camera. So looking in near infrared with Hubble, we saw this in the Pillars of Creation, and this is really kind of cool. You look at all the stars that you don't see invisible. You get infrared has longer wavelengths, looks through that gas, boom, you see all those background stars. So that background blue gas is actually rather tenuous. It's not thick enough to block infrared light. Although the pillars themselves, parts of them are thick enough to block the infrared light. Well, of course, when you get a new telescope like the James Webb Space Telescope, bam, you got to go through and to look at that. So here is the pillars with the James Webb Space Telescope in near infrared. Again, you see all the wonderful stars, but you also see glow from the dust there because James Webb goes out a little further into the infrared and picks up emission from dust. It also goes much further into the red with its mid-infrared camera and finds this and definitely get the glow of it. So we have over the years assembled 5 different interesting views, distinct and interesting views of the Pillars of Creation. And this gives us a lot of scientific information to try and understand what's going on inside the pillars. But not all of these images are created equal, because if you look at this, what you're looking at is they're the same size on the sky, right? This is the same area scale. Unfortunately, when you look at pixel scale, how many pixels are in each of those images, you find that the Hubble visible from 2015 and the Webb near infrared are the 2 that have all the pixels, right? And so those are the 2 that you're going to work with. And these were the main 2 that we worked with for our visualization of the Pillars of Creation, the Hubble visible and the Webb near infrared. One other thing you need to know about the pillars of creation before I get into some of the details is that they're in the Eagle Nebula, and you can see the pillars here pointing up toward this cluster of stars. And the radiation from that cluster of stars, the winds and radiation from that cluster of stars, push away all the low density gas and leave behind these tall pillars that point back toward the cluster of stars. Also, the ionizing radiation, the ultraviolet radiation from the stars, heats the pillars, and you'll see that the top of the pillars glow very brightly. All right? So let's examine a few scientific things. First, we're going to talk about some density and transparency. You can see on the left the Hubble image, and you might think that this tall pillar, what we call pillar 1, or actually we call pillar 1A, is solid. But if you look over on the right, you can see that the central area of this pillar is actually pretty empty. It has a nice dense top, right? The infrared, it's dense enough that the light doesn't pass through in infrared, so it shows that is really dense. But the body of the pillar is somewhat much less dense and somewhat transparent in the infrared. We also could see that a bit in the Hubble near infrared, right? So if we go Webb and Hubble, the Hubble picks up the really dense parts because they appear black in the Hubble, but the Webb has a bit of the glow from the dust that the Hubble doesn't. You can also see it in the small pillar on the right, which we sometimes call the dog pillar. I don't know if you guys can see it, like a terrier with its front paws sticking up in the air. Okay, yeah, we use a lot of these analogies and things. So in the dog pillar, you can see that it's very dense in the Hubble near infrared, which shows off that true density compared to the Hubble visible on the left. If you look in the central pillar, you can also see that there are gaps in the central pillar that don't really show up in the Hubble image. So we can use multiple wavelengths to understand the density structure of these pillars. Then there is the ionized gas outflows. So I told you that the ionizing radiation hits the top of the pillars, and then what it does is it takes that molecular gas and ionizes it, and you get these streams and flows away. And so I'll draw a couple of arrows to show you that the molecular gas is then streaming off the top of these pillars. And we can see that also a little bit in the Webb image. You can see a bit of the same streaming. I blink back and forth. But the other thing you'll notice is that the whole level of the pillar drops just a little when you go to the Webb, okay? So if we're going to model this, the Webb pillar is actually a little bit shorter than the Hubble pillar because it's looking at gas that is at a cooler temperature and therefore is underneath the surface that Hubble sees. And then if we look at the central pillar, you can also see the ionizing flows coming off on the left-hand side here. And it looks a little bit like hair. Matter of fact, we actually use the Hollywood technique for modeling hair in computer graphics to draw that in the models that we used in our 3D, so that we're actually seeing these ionizing flows. They feel like hair, and the Hollywood tools were really, really great to be able to sculpt and sort of art direct the hair, the ionization flows that are coming off of these pillars. What's particularly interesting about the small pillar, the dog pillar on the right, is that you can see it is mostly in shadow here. You can see in the Hubble image. Therefore, the light from the stars, ionization light from the stars, is hitting the backside of this pillar. And you can see here and here, there look like there are flows coming off of it. All right, and these flows then rise up and get pushed off to the left, and we end up with this flow of ionizing gas coming off the back that we need to model for our 3D structure. Then we have the Webb view of it, where you can see that same sort of flow, not really there, but if you look carefully, you can find it in this light blue gas moving across there. So we have these ionization flows in both the Hubble and Webb images. Now, the top of the tallest pillar is the most really cool, interesting things. And you can see that it's got all of these tiny little fingers sticking up, okay? So I told you about the ionization that creates the whole large pillars. Well, also at the top, they have dense pockets at the top, and then I'll create little fingers behind those dense pockets. So these are like mini pillars, and they're at the top of both the Hubble and the Webb images. Then there is an embedded protostar in the central pillar. Okay, so we call this central pillar the Dementor pillar. Those of you who remember your Harry Potter, this looks kind of like a Dementor flying around. And at the top of the Dementor pillar, you can see we have this red stuff, okay? And what is this? Well, you go to the scientific papers and you figure out what's going on here. And the velocity map is such that there's a jet here at the center where this white circle is, and it's coming towards you, and it's blue shifted. The velocities are blue when they're coming towards you in the front and lower, and going away from you up and to the right. So there is an embedded protostar in that white circle area that is shooting out a jet that's coming out the front and out the back on this. And that's what you get to see that we've got a model having a, there we go, having a pillar, a jet inside and coming out of the pillar. There's also another jet that's much easier to see. That's over on the top pillar. And this is down here, and here's how it appeared in the 1995 image. But just to let you guys know what a jet really looks like, here is a 2010 image from Hubble called Mystic Mountain. And you can see up at the top that you've got a jet coming off of this finger up here, and you've got a jet coming off of this mountain here, peak over here. All right, and so this is a common feature of newborn stars, is that they produce these big, long jets. Now, with the pillars of creation, this jet, we've got a 1995 image, and we've got a 2015 image. Okay, and if you look carefully, especially right in here, okay, right in here, you can see that the jet actually moves over those 20 years. Kind of cool, isn't it? Yeah. So you've got this wonderful jet there. Now, it does appear in the Webb, but again, like the ionization flows, it's in this soft light blue, and it's kind of hard to pick out. But it is still there, and we did model it for the for our three-dimensional model of this. Newborn stars. Well, these are the pillars of creation because stars are being created in them, okay? So, there are regions of newborn stars, but you got to look at those and you got to say, all right, where are they? They're embedded in dust, so they aren't so easily visible in Hubble. But if we take these two pieces, all right, you see this little star here, peeking here, and then there's sort of this smokestack with a star above it there. If you look in the infrared, you can see, boom, yes, those are really our stars, okay? And they are associated with it, all right? And one even further, Webb goes into the mid-infrared, and bamba, there you go. Nice big stars. So we can actually tell where the newborn stars are in it via our via multi-wavelength observations. All right, so now I want to talk about the 3D model, and I could spend 6 hours telling you all of the details that we did it. So instead, I'm going to show you a short 2-minute movie that covers the process in a video format. And you'll see that ends with the coming soon, because we usually release our video visualizations at the AAS meeting in January. This product took so long that we ended up not releasing it until 3 months later. So we had this coming soon video to show what we were doing. All right, so let me emphasize a few things from that video. One, that is a huge process. We have an entire team. It used to be just 3 or 4 of us doing this. Now we have 9 people to work on the various aspects. And they include me as the astronomer, Greg as the manager, some 2D image processors, some 3D artists, a video producer, a programmer, and I think so that we have a whole team to work on it. And we use that Hollywood software, the same software that's used on the blockbuster movies. We use it for our visualizations. So we take it and we put it to science. And note that one of the things that we did is we placed it in 3D in the model with the 3 ionizing stars and the pillars. And on the right, you can see how the pillars all point towards the stars. And when we showed this to the scientific expert, she goes, "Oh, you're right. That pillar should be pointed more this way." So you can actually get some science done by doing astrovisualization. And we are also able to sculpt these models to try and match the lighting in the imagery, because wherever the light coming down from the stars hits them, we know that that is facing those stars, and where it's dark, it's, not necessarily facing stars, but the ridges, the ionization ridges that you see in the gold tones from the Hubble image on the right could be matched to what we're seeing in the visualization model on the left. Because honestly, we don't have an absolute sense of the 3D structure of all this, so we have to use the science information necessary that's available. And for Pillar 1B, it was really cool because in Hubble, it's a dark cloud. It's optically thick. You're only seeing the front of it. You have no idea what the shape on the back of it is, except when you look in infrared, it's a bright cloud. It's radiating, but the back of it is what's being illuminated by the stars. So what happens actually is the back of it is illuminated and the radiation from the backside passes through the cloud and we see it out. So we're seeing the backside in infrared, which is cool. So that helps us sculpt the back of this one. I also want to point out that we did multiple effects the way and composited those in. This is the same sort of thing that you do on your normal CG project. Astronomy tends not to do that. They tend to just all do one shot, right? But we have the different layers for the different fuzzinesses around the pillars and applied them into it, okay? And our Pillars of Creation was honored to be selected for the Computer Animation Festival in 2025. Last August, I got to go to Vancouver and present it at the SIGGRAPH conference. And for those of you who don't know, the Computer Animation Festival at SIGGRAPH is the most prestigious computer animation festival in the world. So to be selected for that, it was quite the honor. Now, I don't have time to show you the entire film, but I'm just going to show you the highlight sequence here. Examining their structure in 3 dimensions, they separate into individual clouds. The right pillar is closest and is backlit by the star's intense radiation. Glowing ionized gas streams away from the pillars. The infrared view of the central pillar reveals vibrant evidence of an embedded protostar. The top of the left pillar is directly bombarded by energetic starlight. Dense pockets of dust resist the erosion and create narrow, finger-like peaks. Lower down, jets from a newborn star shoot away from a peak. The semi-transparent body of the pillar lies in the shadow of the dense top. A newborn star blazes at the end of this peak, underscoring the nickname Pillars of Creation. All right, so what is this all about? In being an astrophysicist, it's about combining accuracy and aesthetics, respect for the astronomy, and creating a cinematic version of it so that you get that message out to as much of the public as possible. For 10 years now, I have been the leader of the AstroViz project for NASA's Universe of Learning. And here are 8 of the major projects that we've worked on, including the Pillars of Creation. And our objectives in doing this is, first of all, beauty, awe, and wonder. Okay, we're really trying to stun you with a, wow, this is really beautiful. But we use that as a hook to draw you in to understand some of the science. And to present that science properly, you've got a scaffold concept, you know, what's your base concept, what are you going to build on that, what you're going to build on that, what you're going to build on that, to get to the final point that you want to make. You really have to educationally structure it properly to get your message across. And a phrase that I've used for all of my career, started very early on in my career, is visual intuition. I want you to be able to see things first and understand it visually, because I think that really gives you a good understanding. If you just hear the words, you don't quite get it. You really get it when you can see it. And then I write the script last because I think the script must support the visuals, not vice versa, the visuals supporting the script. And what the end product, the base end product that we get, is that you now have a 3D mental model of the Pillars of Creation. You cannot look at that image ever again and see them as a flat set of 3 pillars all connected. You now know in your mind that they are all separate and they're floating in space differently, okay? And that changes your view of the universe. So if you would like to explore more of what I have done, I have a tiny little YouTube channel where I post most of my visualizations. It's at Frank Summers in YouTube. We have the Astronomy Visualizations playlist. I was a host of a public lecture series for 20 years. I did a podcast of, I don't know, about 15 episodes of a podcast. All right, and so thank you all for your listening to me today, and I'm happy to answer some questions.
Thank you so much. That was amazing. And I just have to say, on a personal note, I remember as an undergraduate, I studied with Jake Pasakoff, and I remember him showing us the fly-through of the Orion Nebula, that 3D, and being so excited about it. And it's just, as soon as I saw that in your presentation, it just took me right back to...
I got to tell you, one of the greatest compliments I ever got was from an astronomy professor like Jay, who said, you know, your fly-through of the Orion Nebula, that's worth 2 of my lectures.
So good. So, any questions from the audience for Dr. Summers? Let's see, do we have any questions in the chat? Just some comments. All right.
Well, I will answer one question that I often get, is that this is not a career path that I would recommend to anybody because there are just so few jobs, unfortunately. I know of about maybe a dozen worldwide of astronomers who get to do the kind of cool things that I get to do. We feel very blessed to be able to work in this. And as I said, I sort of fell into this sideways as I progressed up through my career, and was like, oh, here's an opening on this. And but what I love about it is it gets to combine art and science. It's more STEAM than STEM.
Amazing. Well, thank you so much for your time. We really appreciate you sharing your work with us. It was amazing. And so we can let you go for the day. Thank you.
All right. Take care.
Hello, welcome back to the 2026 Humanistic STEM Symposium. We're going to get started again after our lunch break, and so we will be picking up again with a discussion of the art program at the Hartsfield-Jackson Atlanta International Airport. We'll be joined by Pranisha Reed. She serves as the program coordinator for the Atlanta Airport Art Program at Hartsfield-Jackson Atlanta International Airport, one of the largest and most visited public art sites in the southeastern United States. In her role, she helps integrate site-specific artwork, rotating exhibitions, and performance programming into the daily experience of millions of travelers, shaping how art and culture intersect with public space and civic life. She holds a Bachelor of Fine Arts with a minor in graphic design from Florida Agriculture and Mechanical University. Her work models how artistic vision and public engagement can transform environments and broaden access to creative expression. Please join us in welcoming Ms. Reed to speak with us about the ATL art program. So if you would like to share your slides whenever you're ready, thank you so much.
Hello, my name is Pranisha Reed. I also go by Pre. I work for the Atlanta Airport Art Program. I'm very excited to talk to you all today about the work that I do and my colleagues do. I feel very privileged to have the opportunity to present art on a global stage. We make a joke that because Hartsfield-Jackson International is the busiest and the most efficient airport in the world, that we are managing the world's busiest art gallery. So I can't follow the nice introduction I just got, but I'll add a little bit to it. I'm also from Jacksonville, Florida, though I'm based in Atlanta. So not too far from Embry-Riddle. So ATL Airport Art integrates art into the daily fabric of Atlanta Airport for the benefit of passengers and employees. The art program commissions site-specific artwork, produces and curates rotating exhibits, and manages performances and artist programming. So some of the performances that we do, because I won't talk a lot about that in my presentation, we used to be responsible for the holiday performances. So like carolers coming, sometimes we have dancers that reach out to us and ask if they can exhibit some type of performances to activate different spaces around the airport. So I want to talk a little bit about our staff. We are a small but mighty team. There's 4 of us. We have our interim director, Benjamin Austin, who's been working with the program for about 7 years, and also worked as an intern before he got hired full-time to work for the art program. So he probably has the most experience out of all of us with this specific airport. Jess Bernhardt is our program manager. Lauren Kalotkin is a fellow coordinator, and then also myself. And here's a quote from our interim director, Benjamin. The goal is to use the airport as a platform to elevate local artists and create an engaging environment for passengers. And this is a very informal photo after one of our staff retreats. So let's talk a little bit about the history of the program. So the initiative to display artworks at ATL originated in 1979. They commissioned 14 pieces to be installed at the domestic side of the airport. This is before Hartsfield-Jackson International is what we know it to be right now. So this would have been on, like I said, the domestic side. So you could see works by Curtis Patterson, David Hammonds, Linda Binglis, Benny Andrews, and Sam Gilliam, and others. Approximately 25 years later, a series of new artworks were commissioned to welcome the world to Atlanta for the Olympics in 1996. The part of the airport that was extended would be E Concourse and then eventually F. If you visit the airport, if you frequent our airport, you would notice that E Concourse has the most dense collection of art. Every single boarding gate has a permanent commissioned work. And that's also my favorite part of the airport. So we have art everywhere across the airport. We are constantly thinking about ways to incorporate art in a meaningful way to add to both travelers and our employees' experiences. And here's a fun fact about the airport. So the airport employs more people in the state of Georgia than any other corporation. It's basically like a mini city. So this is our social media wall. It exists on the lower roadways. If you are either parking, you could see it, or if you're walking into the airport after parking, you can catch this wall. This is just one side of the airport. Our goal is to install another set of photos on the other side, but these works were selected by doing a lot of cold contacting folks on Instagram to ask them if they'd be interested in sharing some of their works for this exhibit. So I used a lot of geotags to locate people. So anybody that posted pictures using Atlanta airports, ATL, or just in the vicinity of the airport, I contacted the folks and asked them, like I said, if they would be willing to participate. So what you can see in this photograph is that the bottom right-hand section of each photo has the social media info of the photographer. This was an idea by our former boss. We've recently moved to a different team, but our former boss pitched this idea to us as a way to, give people who are not artists an opportunity to be a part of the airport. So how do we work? As stewards of this program, we wear many hats. We're curators, we're administrators, preparators, conservators, maintenance managers, graphic designers, docents, copywriters, and more. We're very busy. But I really do love my job, and I love that I get the opportunity to work with so many different artists, especially coming from a studio art background. So our program is split up into two parts. We have permanent exhibits and special projects and rotating exhibits. The works on view can be anything from a sculpture, illustrations, photography, paintings, installations, and we're in the process of acquiring animations. The photo to my left is a photo mural site. It's titled Athens, Georgia by Henry Owings. So this work is comprised of many posters from Athens, Georgia, as it is a hub for music. So a lot of these posters can date back as far as maybe like the late 70s, early 80s. It's a really cool work, and this is actually one of the first things I worked on when I started working for the art program about 2.5 years ago. I had to look at this on my computer to zoom in and see if there was anything inappropriate so that way I could take it out. And that's the other interesting thing about working for the art program. One of the things that we have to consider is that people experiencing the art program's works aren't necessarily opting into a gallery experience. So we have to be considerate of why people are traveling. And of course, again, employees, right? You're having a bad day. You want work that can immerse you in a space to make you feel comfortable, engaged. It just depends on the work. People are traveling for vacations, funerals, graduations, stuck at the airport for a layover, and we want to be considerate of where people's minds are when they're walking through the airport. So permanent exhibits and special projects. We have over 1,000 pieces of artwork, and this airport acts as the largest public art site for the southeastern US. There's so much to explore, and anytime anybody comes to take a tour at the airport to see the art program, I always tell them, please wear comfortable walking shoes. So the commission works are funded by the city's Percent for Art ordinance that requires a percentage of capital construction budgets to be allocated towards public arts. So basically, anytime anything new is built at the airport, whether it's somebody fixing something or just something brand new, 1% of those funds goes into a bucket of money for permanent works for the art program. As somebody that's coming from a nonprofit art background, I'm so glad we don't have to seek granting. I think we're very privileged in that way. To the right of this slide, you'll see a work by Radcliffe Bailey, who recently passed away, maybe in the last year and a half. This work is titled Saints. When I see this work in the airport, I know I'm in Atlanta. So if you're heading down the escalators towards the transportation mall, which is where the trains are, you can catch this work, or if you're headed up escalators. Here's a closer look at it. It's a beautiful piece. It's very intricate. There's too much to look at to gather in one trip down the escalator. Here's another popular work. This is called Flight Pass by Steve Waldeck. This work got us a Coda Works award when it was opened. And it's essentially a canopy. It's an immersive space, and it's one of my favorites to just kind of dwell in. You can sit quietly if you want along the moving sidewalks. It's usually very quiet in there. There's a sound component that you'll hear the sounds of regional birds. There's also projection mapping, and there's monitors above your head when you're walking through that space. As of right now, we're in the process of restoring some of the monitors. So give us a minute, and it'll be back to its full glory. This is a prototype of a lenticular print. This project is being worked on by a filmmaker named Ramel Ross. If you're familiar with the movie called Nickel Boys, he's the filmmaker behind that. This probably is not the best video, but I just wanted to show you what it looked like, and I'll rewind it again for just a second. So this process takes a while. As you can see, we're able to animate something without the use of technology. When this project is completed, it will go in a Guinness Book of World Records for the largest lenticular work, or just largest lenticular prints ever. So I'm really excited for that. The work will be Afrocentric in nature, and it will tell the story of Black America, essentially. This is a photo. Well, the photo to the left is a ribbon cutting ceremony that we just had last week or the week before that. Time is flying by. So this is Blue Skies. Our airport just turned 100 last year, so we are still celebrating our centennial. The lease was signed by the city in 1925, and the first flight landed at Candler Airfield in 1926. The original jet terminal was started in 1957, but was replaced by the current midfield terminal in 1980. So that'll be concourses T, A, B, C, and D. So to the left, you'll see our mayor centered. You'll see some of my colleagues, me to the right, my other colleague, Lauren, to the far left. Unfortunately, I forgot to take off my badge before we took the photo, despite people telling me to do so an hour before. But it's a beautiful exhibit. It tells a story of our airport. It talks about the land, the people, the fashion. We even have a maternity dress from an airline. And we have these boards, which you'll see at the top right on the second image. We have about 3 of them in the exhibit, and they are working. So they flip throughout the day. And I love the sound of it. The carpet was designed to mimic the runway, and I'm sure children will have a field day with that one. So we are collecting animations. We've commissioned a couple of artists to create things for the art program. We have about maybe 5 monitors right now that are dedicated to just art program programming. We are also in the process of getting some of these animations displayed on the boarding gate monitors. So I'm excited to get that done because we've also commissioned an artist to create work for FIFA World Cup, which will be coming to Atlanta this June. And we're so excited for that and gearing up to have a lot of special projects related to that. We'll be activating the airport with a few works that will act as like scavenger hunts. And I don't want to say too much because I kind of want to leave some things to surprise. But yes, this work is by John Andrews. It's hand-painted stills to show the story of this cute little luggage moving through the airport. And I'm going to speed it up a little bit because there are other animations. There's about three videos. 2 are animations. 1 is a music video. So there he goes. Oh, here, I'll let it finish a little bit. So by John Andrews. And then the next one is a work by Thea Rose, who did a stop animation crochet work. So we're thinking about a lot of different ways to incorporate art and to select artists who are making works that will engage viewers. One of the things that my boss, our program director, or our interim program director, Benjamin Austin, wants to do is create an, a movie theater. So like a small passenger-sized movie theater that your luggage can sit next to you. So I'd like to think that we're slowly building on that by having these animations. So this is a work by John Andrews. So I'll pause that there. I just wanted to kind of give you a sample. So this is the only one with a sound component. The thing about displaying any type of video with a sound component in the airport, it has to be ADA compliant. So we have to include subtitles. The other thing that we acquired about 2 years ago, shortly after I started with the art program, is a short story machine. There is a company based in France that creates short story machines, and they print short story machines on demand. We have cited this machine near one of the coffee shops. That way while folks are waiting for their coffee or after they've grabbed their coffee, they can grab a story. So it's thermal printed paper, no ink required, which we love. There are 3 buttons on the machine, so we can print 3 different types of stories. It can either be a children's story, an adult story, or a story for Spanish speakers. There's poems, fiction, nonfiction, you name it. And this sign to the right says that you can submit your own short story using the QR codes. Fortunately, this company that created the product, they also come with a backlog of stories that they are constantly adding to, and they alternate stories based off of what season we're in. So if it's the holiday season, they sprinkle in some holiday stories. If it's getting close to Valentine's Day, we're going to see more love-related things. But my favorite part is that folks can have their own story shown and shared with the world. Rotating exhibits. So I work primarily with rotating exhibits. This is my thing. I love it. My favorite part about the work that I do relating to rotating exhibits is going on studio visits. I love to see the way artists are working and thinking. You can only imagine what people are thinking about in their studio spaces and how they are tying a lasso around an idea and bringing it into reality. So the work above is by Tori Tinsley. It's called Everyday Carry Items. I loved this piece when it was up. We just deinstalled it maybe 2 months ago. And the work is centered around how this artist, Tori, was feeling around COVID. She kind of started focusing on being prepared in the case of a disaster. Somebody gifted her a book about objects you should keep on your person in case of a disaster. So that's what this is. There's a lot of objects in it, and everything is made out of paper, tape, and paint. Except for the wood stand that the donkey and the human lounging or laid out is laying on top of. So there are over 25 rotating exhibit spaces utilized for the exhibits that are on view from anywhere from 3 to 18 months. We have the atrium gallery, which is accessible pre-security in the domestic atrium. That's probably our shortest rotation time, and I manage those rotations personally. And that space rotates every 3 months. These cases on e-concourse, it's anywhere from 12 to 18 months, and sometimes longer. It just depends. But on average, 12 to 18 months. So we're constantly working to install folks and deinstall and thinking about how to be prepared for what people need. If there's technology in your case, we're going to need a timer so that way things turn off and don't get overheated in those cases. So this is another rotating exhibit space. I mentioned our transportation mall earlier. This is the lower level where the train is located to take you through the airport to get to your concourse. So we have 4 photo mural sites that exist between our permanent exhibits. I showed you flight paths earlier. This is an example of what you can find between them. So if you're in the airport, next time you're flying through ATL and you have the time, I highly encourage you to take the walk on the transportation mall level. We have moving sidewalks, so it doesn't make the walk as bad, but there's always something exciting to see. This show is titled When I Look and You Look Back. It's a portraiture show featuring 4 photographers. To the left, you'll see the work by Peyton Fulford. Top right, this is a photo from Talicia Tucker's exhibit, and bottom right is a photo from Jose Ibarra's exhibit. The last one is Kendall Besant. This is another rotating exhibit space. It's a photo mural site on the domestic side. So again, this is something that's accessible to folks who can see it without needing a ticket or a flight. This work is by Fabian Williams. It is our Jimmy Carter mural that we put up shortly after Jimmy Carter passed away. And it also features his wife, Rosalind Carter. To the left, this is the underpaint for this artist. This is his style of creating. I thought it was important to show you this, just to show you how this artist thinks and how they are bringing their ideas into reality. So he uses a hieroglyphic style to kind of lay out the intention for the work. You probably can't see as clearly as I can what he says. So you see like the top left, it says Jimmy Carter, it says Jimmy, and each of the hieroglyphs are associated with the letters. At the center, bottom right, it says married. That's so dope. And then it's like, I know, right? I love it. It says so much about Fabian's personality and also the research that he put into learning more about Jimmy Carter to depict him accurately. And that is still up now. This is Grow Through What You Go Through by Victoria Duggar. I love this piece. We just installed this not too long ago. And so sometimes the artists that we work with, they might opt into being, to have someone install their work or ask someone to install it for them. This is Heather Bird Harris. She makes work about ecological disasters. The shapes of the work is based off of the geography affected. The work to the left is about data centers popping up. The work to the right is about watershed and like issues with our water. So we have the ability to talk about a lot of different topics at the airport. I'm really glad that Atlanta doesn't shy away from current issues. This is the work I just installed 2 weeks ago by Congolese artist Masela Nicolo. He lives here in Atlanta. He uses lanterns and screwdrivers as a form of like protection. Okay, so let's talk a little bit about curatorial challenges. This is a beautiful work by Midori Frey. It's called Day Tripper, and it involves technology. Love this piece when we installed it. Something strange happened. The case flooded. We had to deinstall everything and reinstall. You just have to expect the unexpected working in the airport. There's a lot of ground to cover. There's only 4 of us. So sometimes we have other eyes that can alert us to issues going on. But I'm glad Medora was really understanding. So we deinstalled everything. She washed this canvas and then reinstalled everything. This is Lightning Struck. It's about a former community that existed where the Georgia World Congress Center sits. This is another example of Atlanta not shying away from its past. So Atlanta officials decided to create the Georgia World Congress Center and pushed out this neighborhood of people. And we have an exhibit to talk about that. And I remember before we installed it, we asked our boss, is it okay if it says Atlanta officials did blank? I mean, it says that a lot throughout the exhibit. And our boss is like, yeah, do it. This is a work by Michael Reese. These are cyanotypes. This is one of our larger exhibit spaces. Separate from the small cases, we also have full exhibits that can show a full exhibition. So that is the end of my slideshow. Does anybody have any questions? I just wanted to set aside some time for that.
Thank you so much. That was fascinating. I just flew through the Atlanta airport yesterday, and I really appreciated a lot of the artwork there. I saw that lenticular piece. That was amazing. So, yes.
Yeah, we'd love to get that type of feedback. Thank you.
So, can you see in the chat? Kelly Vaden has a question there.
Let's see. Yes, I'm reading it now. Oh, screen display. That's a great question. So I don't know if I can say a lot, but there is something coming very soon. Yes. The difficult thing about technology is maintaining it. I'd like to see that a little bit more too, especially LAX, having done that so well. You know, every year we go to an annual Arts in the Airport workshop. One of my friends says that that's so niche, and it is. But LAX told us more about their process, and it's so impressive. I think that they are really leaders in a lot of what airport art can look like.
Are there any questions from the audience? I was wondering, with the rotating display, with the rotating works, how do you choose that? Do you tend to focus on Georgia, Atlanta-based artists? When you go into filling one of these displays, do you have something in mind, or do you go in with just a totally open mind and see? How do you start this process of choosing these exhibits?
That's a great question. So fortunately, we have the freedom to make selections on our own as a program. So essentially, it's a combination of knowing artists exist and wanting to show their work. We accept proposals on a rolling basis, and we don't exclusively show regional artists. This morning, I had a meeting with an artist that is based in Marrakesh. We might show one of their murals to take a photograph and turn it into a photo mural, I should say.
Excellent.
So we're thinking about a variety of ways.
when you deinstall the works, what tends to happen to them afterwards? Do they go on to other museums, other gallery settings? Do you know?
Okay, so when we deinstall, we technically we pay, oh, this is the other thing. We always pay all of our artists. Nobody is working for free because people have bills to pay. So when we deinstall artwork, we give it back to the artist. They have the option to, decide where they want to show it next. Sometimes this might be the first stop, and we have a lot of conversations with like a curator or an artist about how to refine the exhibit for the next space. And if anybody approaches us to ask us about purchasing a work, they're able to do that on their own. We direct them straight to the artist. So we don't take any payments and just let people do their own thing. One of the other things I didn't show that I wish I would have, and I just forgot about it, is our youth art exhibit spaces. And sometimes people want to buy youth art. And so we direct them to the teachers that manage the work.
Excellent. And with these rotating artworks, what is your timeline for if you have a space that you know that you're going to have to find artwork for? How long does it take you to put together that exhibit?
A smaller exhibit, like a one case, it can take anywhere from like 3 months. For me, I would say on the administrative side, I want to make sure people get paid as soon as they install. So I always tell them the city's slow to pay, make sure you do your paperwork. But it just depends. Sometimes artists they'll send you their proposal, but they won't send you their information for a label, or they won't do the business part of it. And you're like, hey, we got to get it done. But the bigger exhibit spaces, it takes about a year. So anywhere from a year to 6 months. On the short time, maybe like 3 months.
And given that we're coming from an aeronautical university, do you think that there's any special background or preparation that would be useful for somebody who wanted to come and work for an airport art program specific to being in the airport?
Ooh, that's a really good question. I'm sure there is. I don't know if I can answer that outright, but I can say this. I think it'd have to be a situation where that person with their unique skill set needs to understand the way the art program works in itself, and then ask themselves how they want to work with the art program. Like right now, we have an exhibit up with Georgia Tech, and it shows different works from different labs. So there's like a few different, maybe 5 or 6 different professors that have created works, not artwork per se, but like an exhibition around the lab work that they're doing.
Very cool. Well, thank you very much for your time and expertise. That was a fantastic presentation, and definitely it was really fun. A lot of us being so close to the Atlanta airport, we see this artwork when we travel to and from the university, so it was really interesting to hear some of the behind the scenes of how that artwork gets there. So we will let you get on with your day, but thank you very much for taking time to present.
Thank you. You all have a wonderful day.
You too. Bye.
Bye.
Great. We're back from our brief break, and I would like to introduce Andrew Carruthers. A native of Oxfordshire, England, Carruthers worked at the Lawrence Berkeley Research Labs in California before deciding to follow his passion for building stringed instruments. Returning to the UK, he studied at the Welsh School of Violin Making and Repair. After graduating, he joined the restoration workshops of Bein and Fucci in Chicago to apprentice under the guidance of master cello restorer Russell Wagner. In 1996, he opened his own workshop in Santa Rosa, California. He's been awarded 2 silver medals and a certificate for cello tone and a certificate for violin tone from the Violin Society of America. He uses the medium of violin making to explore both the natural world and questions about violin acoustics and aesthetics. So please welcome Andrew Carruthers. Please feel free to share your slides whenever you wish.
Hi, yeah, so thanks for that introduction. We're still good? Okay, so I'm actually in a hotel room at the moment, so I thought I'd just give you a quick picture of my workshop, which is in my garage in Santa Rosa. I work by myself there, and for the last 35 years, I've been working on restoring valuable old instruments and making my own. So, okay. So, what I'm going to talk about today is a project that I started during COVID when work slowed down, and I had some time to explore some of the ideas and questions that I've been accumulating over all my years in the trade. And what I did was I started a series of instruments that I call offbeat violins, where I began to investigate particular aspects of violin making that interested me, but pretty soon that led on to considering other questions. And so in that way, the violin making became a sort of investigative lens on the world. And though these offbeat violins aren't traditional, I wasn't trying to change the direction of violin making. I was rather more interested in examining some of the peculiar things that we in the violin world take for granted. And I just want to note that a violin and a fiddle are the same thing, and I'm going to be using those two words interchangeably. So, in order to understand where I was going with these ideas and with this talk, I need to explain where violin's been. So, for the last 300 years, the sort of pinnacle of the craft has been to create exact replicas of a handful of violins that were made in the 1700s by 2 or 3 violin makers. And this rather odd situation of looking back has come about because the violin is rather a unique thing among man-made objects, in that it evolved over about 150 years. It sort of started in the 1500s, and that design evolved very slowly until about the early 1700s, when Stradivari came along. He kind of nailed the design, he sort of perfected it. And by that I mean that for a string tuned at a particular pitch and bowed and stimulated with a bow, and having that sound amplified by the you can't actually get more volume and a richer tone than you can with these instruments that were made, at that period. So what we've been doing ever since is copying those things as carefully as we can in hope of unlocking the secrets of the sound. And in many cases we've equaled that, but we've never actually surpassed it. The other thing that we do is, because those instruments are so valuable and sought after these days, and another peculiar thing about violins is that they're actually very durable. And these 300-year-olds plus up to 400-year-old violins are still in the world and still being played regularly. But the population's grown, and only a few, less of these instruments have survived, so they're very sought after and very valuable. So what we do these days in violin making is try to make exact replicas of them, and that means making our brand new instruments look antique. And in the last few years, 50 years or so, this has come to a real sort of peak where people are spending up to double the amount of time actually trying to make their instruments look old as the time that they put into making the new instrument itself. And there's nothing actually wrong with this, but this sort of looking back, for me, after about 35 years of doing it, I began to feel rather like a musician who'd been told that, well, all you can do is play Bach because he's the great master. So I started looking for ways to do something a little more interesting with my violin making time. So my first idea was to make a violin that showed how it was developed. And I wanted to do this because as we carve a violin, as we make it, or a cello or a viola, it goes through all of these stages that are very attractive looking, rather sculptural. And all of this carving, this lovely texture and line and rhythm that happens in there, it gets erased as we smooth the surfaces and finish them. And I'd always thought that it would be wonderful to create an instrument that sort of showed its work, rather like a math proof. So that's what I did. And when I started out on this viola, I thought, well, what I'm going to do is I'm just going to make the instrument, and whatever tool marks appear, I'm just going to leave those, and I'll finish the instrument and see how it looks. But as soon as I started carving, I started seeing all these patterns in the surface of the wood, and I started trying to make them more attractive. And here you can see on the back of this instrument, the left half has one sort of carving pattern on it, and the right half has...
Andy, I think we can't see your image.
Oh, really?
We're just seeing your workshop.
Oh. Well, that's a little difficult. I wonder what we can do about that.
There we go. That's it. Perfect.
You can see an image here. Okay, so it's not going to preview. So yeah, okay. Okay, let me go back a bit. Oops, not that. Sorry, I'm losing control of this. Okay. Well, it's kind of in edit mode, so they're not going to look as good as they could. So yeah, these are the offbeat instruments. This is a traditional violin, the sort of thing that we're trying to copy these days. This is a tonal spectrum of instruments to demonstrate how wonderful the classic period instruments are. And this is me experimenting with tool marks on the violin. So are these reading better now?
Yes, that looks great. Thank you.
Okay, good. Okay, so I realized what I was doing was making aesthetic decisions. And I had this personal revelation of something that I'm sure is sort of common knowledge to most artists, but there's certain tools that you can use, things like line and texture, that are used by all artists. So for instance, in poetry, you might talk about narrative line, or the pacing or the rhythm of the narrative, rhyme, and so on. And those tools are exactly the same things that you can also use in painting, for instance, or in dance, to tell a story and convey emotions to the audience. So keeping this in mind, I went on to try and finish the violin, and I started with just a uniform coat of varnish, and fairly attractive, but maybe a little boring. So I tried to break up the surface by adding some larger lines onto it. And in this case, it's certainly attractive looking, but perhaps a little chaotic. And it's nice to be somewhere in between. So I carried on, and using techniques that I'm quite familiar with from trying to make antique-looking new instruments. We call it antiquing. So using my antiquing techniques, I refined the surfaces by adding patina to the low areas and highlighting the high areas as if they'd been worn naturally. And I came up with something which I thought had a fair amount of texture and line and rhythm to it. Here's details of the scroll. I was always trying to make things look sort of organic, because that's something I think is quite attractive. And the sides of this instrument actually reminded me of the skin of a reptile of some sort. And so I thought, well, I could actually use a natural object as a source of inspiration for the aesthetic decisions that were being made. And so that's what I did with the next violin, and I decided to base it on a turtle. And the way I went about it was to use the same sort of color palette as a turtle shell. And I took those gouge marks that you saw in the viola, and I sort of formalized them. They were more random in the viola, and I'd sort of made them symmetrical. And these were supposed to sort of suggest the sclerets, or the plates that you see on a turtle shell. So one of the things I liked a lot about the way this came out is it has this sort of recursiveness. You can see in, I don't know if, yeah, where you're getting these sort of cell patterns, but then within the cells there's sort of repetitive, sort of recursive nature. And the overall effect, I think, is has this rather interesting effect that it appears that you can sort of look inside the instrument. It's a sort of like an open sponge texture that maybe you could travel into if you were small enough. I also copied other features that I saw in reptiles and turtles. In particular, this F-hole was based on these extraordinary iris patterns that you'll see in some reptiles, these sort of slit irises with the notches, and so these notches became a feature. So, moving on, the next two instruments were a study in variability. And variety. So working on that turtle fiddle, it sort of reopened my eyes to the natural world. And I was actually, my undergraduate degree was in design and ecology, so I've always been interested in nature and the natural world. And thinking about the aesthetics and reflecting on what it was about these old, worn, handmade violins that make them so attractive to us, I realized that the violins themselves actually resemble natural organic forms in a number of ways. And one of the characteristics of natural objects that's particularly attractive and engaging to us is a quality of that I call limited variability, where at first look everything looks the same, but as you as you keep on looking and become familiar with these things, you'll see that everything is as in natural objects. You get a variety, so you get variations on a theme, and as you become familiar with whatever the theme is, you become more sensitive to these variations, and that's what holds our attention to them. So I thought that perhaps if I could understand the causes and nature of variability a little better, perhaps I could make instruments that were just as attractive and engaging to us as the old violins are, but perhaps I'd be able to get there without resorting to making these extremely careful antique copies of them. So, what are the sources of variety in objects? Well, I kind of got it down to four main sources: design, execution, materials, and age. Where the design is the deliberate variation that was made. So, what was the violin maker in this case doing to make this particular instrument different from the last one? What was the deliberate choice that was being made? And then with execution, well, how well was that that design carried out? And that might well be limited by the skill of the violin maker, you know, how well he was in control of his tools, or what accidents happened along the way, and all of those things will add a little variety into the finished product. The materials used are very important because different materials react differently to the making process. They react differently to the tools that are being used, and they also age differently. So yeah, so in materials, if you think about wood, I mean that's something that has a lot of natural variety in it. Each piece of wood is slightly different as compared to something like steel or plastic, which the material is going to be very much the same from iteration to iteration. And then the final thing that happens, objects that we finish, they go out in the world and they get worn and used, and then over the years they accumulate the marks of age. And in violins that have survived a long time, I mean, that's particularly important. It's sort of a major factor. I mean, the violin on the left, the dominant thing that you see there is the effects of age. So, yeah, I set out to make a couple of instruments that sort of explored these various factors. And in thinking about it and researching it, I came across the work of Alan Turing, who is, of course, famous for his work against the Enigma machine and also for inventing or laying the basis of modern computing. So later, after the war, he got very interested in morphogenesis and the question of how variety comes about in nature, and why is it, or how can it be that, let's say you've got 100,000 oak leaves from a tree, how can each of those oak leaves be recognizably an oak leaf, yet each one is individual? Or how does every leopard or every tiger have its own individual pattern? So I started looking at this, and I found somebody, Kiram Dundar, who's a design teacher in Istanbul, design professor, and he's been working with these patterns for years. And I asked him if he would be able to generate me Turing patterns that were bounded within the shape of a violin. And we got together and he generated a number of patterns. So what happens here is you have a seed to the pattern, and then depending on the variables involved in the equations that are driving this program, it will form different patterns. But the pattern actually sort of reacts with itself. It actually comes and hits the boundary, and it sort of bounces back and reacts with itself. And under certain conditions, these patterns will just infinitely keep on varying. It's called an unstable reaction. So this was, I took as an example of design variety. So instead of actually designing each individual instrument with a different pattern to it, I was going to leave the computer to come up with a new pattern. So every time you would run this program, you would get a different pattern. So then I moved on to the next stage of the process, executing the violin, the pattern onto the violin, and I used hand techniques to transfer the design onto the violin, just carbon paper. And then I carved the pattern in by hand, and again, this was to introduce more variety into the finished instrument. And I think this amount of variety gives kind of a more organic look. Then I went on to finish the instrument using some of the antiquing techniques that we've developed in violin making, adding dirt, wearing highlights, polishing and stuff. So I was working on this and I was posting pictures of these instruments on Instagram, and at this point I heard from Christy Reynolds, who is your Symposium host, and she said she was very interested in these patterns because they resembled something that she'd been working on previously. And so Christy, would you like to say a few words about the patterns that you were working with and why you had these patterns and how they were derived?
Yeah, absolutely. So these patterns, my background is fabricating telescope mirrors. So I work on ultra-precision optics for telescopes. And at the time, we were working on a telescope called the European Extremely Large Telescope, which is a 39-meter optical telescope. It has a primary mirror made up of 798 individual segments. And in order to make it possible to create these segments, we used CNC machines to polish out the curvature in the glass. The problem with that is typically with CNC machining, you'll raster back and forth. That was leaving behind a very regular pattern that was that would cause diffraction spikes in the optics. So the task that I was given was to figure out a pattern that we could use with the CNC machines that would visit the entire surface without ever crossing itself, but be randomized. So I wrote the MATLAB code. This is the algorithm right here that will produce these random walks. So first we create a grid. We set our boundary point. Usually this would be a telescope mirror, but in this case we made it for a violin. And next we fill this. This is called the Aldous-Broder algorithm. It creates what's called a spanning tree. So we add nodes to the tree that visit every one of those grid points. Got that. Then we add another grid, and then we find the points that neighbor that spanning tree. We drop out the spanning tree and then create a walk that walks along those remaining points that had neighbored the spanning tree from the Aldous-Broder algorithm. And that gives us a path that visits the entire surface in a random order without ever crossing itself. Every time you run the algorithm, you get a completely different pattern. So this was the unicursal violin pattern.
Yeah. So yeah, what's wonderful. This is a yeah. So this is rather similar to the Turing thing in that every time you run it, you're going to get a different pattern. So variability is built into this. Every time you make a violin like this, it's going to be slightly different. And Christy ran patterns for all of the different panels. So we ran them for these are going to be the sides of the violin, and the back and the top. We also we also ran patterns for the scroll of the violin. And then so in this case, I've knocked some of the variability out. So instead of doing handwork on the instrument, I had these cut with a CNC machine, which not only carved the shape into the violin, the arch of the back and top, but then also superimposed these unicursal paths onto it. So going on to finish it, I used a mixture of inks and pigments that actually separated as they were drying. So it, again, produced a little more variability. I didn't know exactly how they were going to dry. It sort of created a pattern as the inks dried, the inks and pigment mixture. And then after that, this is the finished back of the instrument, and I've put it through my antiquing process again, where I've knocked off the highlights, the areas that would get worn, and I was really quite. At first, I didn't like this, but it grew on me a lot, and it has another characteristic of natural forms in that the more you look, the more you see, and you can go deeper and deeper into it and keep on seeing new stuff. And so, yeah, this is characteristic of natural objects, but with many of the man-made objects around us. I mean, if you look at a plastic cup, it's you know, it might be fairly interesting from a distance, but as you get closer, you're not particularly getting a lot more information at a certain point. Whereas with this, you know, each little region of the violin back had more and more texture and color to it. Here we're seeing little bubbles that are in the varnish. And it's also, the other thing is, back to this sort of theme and variation, there is a theme to it and a line to it. I mean, this color here is repeated over here with a slight, you know, more blue variation here and maybe a little more white over here. So this theme and variation thing that you see in nature that is naturally attractive to us. Here's the path that was carved into the scroll of the instrument, and on the top of the instrument, variability coming from the materials used. So the top and the back of the instrument are made from different woods. The back of the instrument is maple, which is fairly homogeneous, but the top has hard and soft grain lines, and the interaction of that material with the machining process gave a different result. So variability from the materials used. So nearing the end of my presentation here. So the four fiddles that I've shown you were based or investigating things to do with aesthetics within the violin world, and also the same sort of things in the natural world. But I made about 10 of these instruments in all, and other ones were more based or investigating tonal aspects of the instruments. So what I got from this was definitely a deeper understanding of the elements that we use in aesthetics. I also found out a lot about violin. Well, I got a much more intuitive sense about the way these violins function tonally. And one of the big questions I kept on getting was, how do these things sound? How does this carving and texturing on the outside of the instrument affect the tone? And it was actually a very good question because, as I say, in our trade, we copy these old instruments very, very precisely. You know, the graduations or the thicknesses of the backs and the fronts of the plates are copied to within tenths of a millimeter, thinking that, you know, this is critical for the sound. What I found was that this actually didn't make a lot of difference, and the sound of most of these instruments was within the range of variability of tone that I get normally with my regular instruments. So I think one of the biggest lessons I've learned, and I think the final thought I leave you with, is that well, let me say, I did make a couple of these instruments using some of these features, but just simply in a decorative way, but without any sort of question behind them. And that left me with the idea that I think that the most interesting stuff, and maybe it's what you might call art, I think that happens when we're asking questions and about something and trying to find answers, exploring. Whereas the two decorated violins, I had pretty much the idea of how they were going to look at the end, and that to me is what craft does. We're setting out with a known end result in mind and doing our best to get there. So I think that's an interesting distinction. Anyway, I'm going to leave it there, and I'll take any questions that you might have.
Thank you so much. I don't see any questions in our chat this afternoon.
Okay.
Do you have any projects underway for another offbeat violin?
I've actually, well, kind of relevant to what I was just saying, I've actually kind of come to the end of the questions that that have occurred to me. I would do it if I had interesting questions to answer, but it's gotten to the point where I'm just making them for decorative purposes, and it's not really that interesting to me. And so I've gone back to making the regular violins, but sort of armed with some of the insights that I've had and technical things that I've discovered along the way from doing these. I'm working on an experimental guitar at the moment, but as far as violins go, no.
All right. Well, thank you so much for joining us today. We really appreciate your time and expertise. Oh, wait, there's... Oh, I was curious if you've used lasers to carve patterns into violins.
I've thought about it, and I haven't. I think you could get some interest. I mean, yeah, you could get some very interesting effects. I mean, it would add some color as well, since I think the wood would burn. And that would be another way of adding, surface texture and surface pattern. I haven't done that, no.
Well, thank you for your time. We can let you go. Really appreciate you joining the symposium today.
Well, thank you very much. It was a pleasure to do this.
Thank you. All right, we're going to start our final events of the afternoon for the 2026 HSTEM Symposium. So this is Ralph Zeman's documentary titled MiG-21 Project, which documents his creation of the MiG-21 artwork. So I am going to go ahead and start this, and then afterwards we'll have a recorded conversation with Ralph Zeman and his team talking about how they pulled this project off.
Art has to challenge people, and if you can make a difference, then I think that's really important to do. You know, I'd always see these beaded animals, beaded objects being sold by the side of the road, and it was really like looked down on. People would say, oh, you know, beads, it's shitty, it's curios, it's made for tourists, it's rubbish. I always really felt like they were given short shrift because the amount of skill and talent to like do this work is just phenomenal, and the amount of patience that goes into it. The idea was to like elevate beadwork. We're gonna make stuff out of beads that's gonna like take people's breath away.
There is no Africa without beads. It connects. If you go deep with Africa, you find that it's the one thing. So that's why you see beads are all over.
We've been doing these things before at home. We've been doing this when we were very young, like those small motor cars, you know. So when I saw the guys doing the same thing, just doing the frames of the animals and different frames of the art, then I said to myself, I think I can venture into it very easily.
To me, it was like an avenue whereby I had to survive through. I decided, if they can do it, why can't I do it? And then I joined in.
The nice thing about beads is no longer African. It's something for everyone. It makes people to belong.
You know, as a kid, I had like African beaded animals and sculptures and things in my bedroom. I grew up with a Ndebele nanny, a lady who brought me up, who was like a mother to me. She would go home for her holidays, you know, a month every year, and I would miss her terribly. And when she came back, she would always bring beadwork. So yeah, I mean, it is personal in a way.
To understand Ralph's work, I believe you really have to understand who he is and where he comes from. He grew up in South Africa during apartheid. It is one of the most important aspects to all of the work that he creates.
The MiG project is number 3 in a trilogy of weapons of mass production. The idea was to take these weapons of war and weapons of destruction and to repurpose them as art, but also to have a conversation about the arms trade, about the militarization of police forces, about the proliferation of weapons around the world. They say that 40% of the world's corruption is run through the arms trade. We started with the AK-47. It's the most mass-produced weapon of all time. The idea was to start manufacturing these non-lethal AK-47s that look really beautiful and exporting them to the rest of the world, while at the same time creating employment and jobs in South Africa. The second in the series was the Casper. We wanted to tell the story of how this vehicle that came out of Southern Africa winds up on the streets of America doing exactly what it did in South Africa. Seeing this Casper covered in beads, people were curious and they came out and they touched it and they felt it, and there's this belief in African culture that when you can touch something you can take its power away. So that was a conversation starter. After that, I was sort of inspired to do something bigger.
Он стал самым массовым сверхзвуковым истребителем в мире. Его стремительные очертания, казалось, воплощали саму идею полета на больших скоростях. Это был МиГ-21.
It goes at twice the speed of sound.
It was a bit like a sports car, super fast, super light, but had no range. The MiG is like the AK-47 of the skies, robust, cheap, and easy to produce in quantity.
Doing some research, we found out that the MiG-21 was the most mass-produced supersonic fighter aircraft of all time.
More than 12,000 MiG-21s were produced over the years. That's way more than any Western fighter.
It really emerges as a symbol of Soviet development. It was really the height of technology during the Cold War era.
The MiG attacks weren't always particularly accurate, but just that psychological effect, it's pretty awe-inspiring. I mean, nobody likes being bombed, and nobody likes a supersonic fighter and afterburner flying right overhead you.
It's a terrifying experience. Certainly the people and ex-conscripts I've spoken to were absolutely terrified when they were subjected to aerial attack. And it's still in service today. It's used by Chinese military, it's used by the Indians, the Middle East, to great effect by the Syrians, the Egyptians. It's used in North Africa. The Cubans employ it.
The MiG-21 was the quintessential African MiG. I mean, if you go from North Africa, you go down to Sub-Saharan Africa, just so many countries had the MiG-21, more than any other fighter type.
South Africa got embroiled in the Angolan Civil War. And on the one side, it was South Africa backing up UNITA, and on the other side, the Angolan communist parties. The Cubans were doing the fighting.
Of course, the Angolan War was a war by proxy.
The Americans on one side, the Russians on the other side.
The Americans supplied UNITA with the Stinger missiles. They were put to good effect, of course.
The Russians gave them these MiG-21s.
And then it fulfilled both roles, ground attack and air-to-air.
In the hands of a competent pilot, it could mix it up equally well with the F-1 Mirage.
For the first time, it gave an African country some true air power.
One can argue that the South African border war is really one of the first and pivotal steps towards a free and democratic South Africa.
One day he said, you know what, Marco, why don't we just do a fighter jet? And I said, that's the most amazing idea ever. Let's find a fighter jet. And
we were trying to find an aircraft in South Africa where we couldn't. It turned out that the entire South African Air Force had actually been sold and was no longer in South Africa.
I called up my buddies over at Draken Aerospace down in Lakeland, Florida, and they happened to have several MiG-21s.
The MiG had been sold by the Polish Air Force. They bought a whole job lot of them, so there were dozens. But because there were no service records for them, they couldn't use them.
I was able to get them to donate one of them.
They said, is it for a good cause? I said, yes, it's providing jobs and work in Africa, and we're putting kids through school with the proceeds. And they said, yeah, you can come and take one.
It was just the one that looked less beat up. Also, there was a rainstorm coming, and we're like, that one will do, let's go.
Every single MiG had its own distinct number. This was 8917, I believe. 8971, I'm dyslexic. If you go on Google or whatever and you put on MiG-21 number 8971, it suddenly starts populating with photographs and articles about this plane, and there's pictures of it when it was service in Poland, there's pictures of it flying, there's pictures of it landing, there's pictures of it in this bunker which was built into the side of a hillside with all the ordnance laid out around it. People did art. We found paintings of MiG-8971. We found models with the number on it. And James Thornton and Marco Gruhl with DT Care, they managed to track down the original pilot in Poland.
Nie mieliśmy samolotów przydzielanych jak jest w innych państwach, ale mieliśmy swoje ulubione. Ten na przykład samolot doskonale kręcił pilotaż, nie miał żadnych takich dziwnych zachowań. Latając tutaj chociażby w Gdyni, można było zobaczyć piękny hel, piękne wybrzeże, a to najpiękniejszy widok, nazwę to z biura, jaki można posiadać. Posiadał podkadłubowy zasobnik do wykonywania zdjęć z różnych wariantach, zdjęć perspektywicznych, panoramicznych i do prowadzenia rozpoznania radioelektronicznego. Właśnie takie zadania również wykonywałem na tym samolocie.
It was disassembled in pieces. The part of the fuselage, part of the tail fins were off, the wings were off, and we had it all craned onto the back of a flatbed. We had it sent over to Los Angeles. We had to use a crane to get it over, to get it into its current resting place. That in itself was a mission. I mean, moving this thing, we had to hire riggers and forklift trucks and cranes and get it off there and get it together, and then, you know, get the wings on, get the tail on, get the nose on.
My part in the whole operation, other than getting in the MiG, was, as we agreed at the Jamba Juice in Lakeland, Florida, was that he goes ahead and does the beating on the MiG, and I'll put the kids of the gentlemen who do the beating through school. 18 kids, now 21, 22 kids, I believe that we have, that we've brought several along the way. We were able to redo their entire schooling and start microfinancing businesses, and it's really exciting.
The idea is we could sell it, we could donate the proceeds to humanitarian causes. We wanted to put part of the money into education in Africa and in the US. We've partnered with DT Care, which is a non-profit. They've been a partner of ours all the way through this process. They helped us procure the MiG. I know they feel as passionately about this as I do. The MiG project is to take most mass-produced supersonic fighter aircraft and to turn it from a machine of war into something looks beautiful, that changes the meaning of it, and that ultimately winds up saving lives instead of taking them. Yeah, look, it's one thing to say, hey, I want to beat a MiG, and the next thing you've got a 48-foot MiG sitting in your studio staring back at you, and you go, what the have I gotten into, you know?
Seeing it for the first time was a big deal, you know, like it's a fighter jet crammed into a big room that's just barely big enough for it. And it has a presence.
I was thinking like a Cessna. Like I did not understand the scale to which this project was. It has all the attachments, and if it doesn't have the attachments, we're making the attachments, you know? So it's got the missiles, and it's got the cockpit and the seat and like all of the flaps, and the tail comes off, and the plane breaks in two if you need it to. And so
the first time I saw the MiG, I looked at it and I said, there's no surprise here. What else do you expect? You're working with Ralph Zeman.
He said, Pretty, can you beat a wing? I said, wing? He said, yes. I said, a wing of a plane? He said, yes. I said, yeah, I think I can do it. Imagine a wing of a plane, how big it is. Then when he sent the picture on the group, the video, I was like, what is this? You have graduated from Casper to a plane.
It's very surprising many people. How can we do the jet in a bidded jet? Yeah, it's quite amazing. We are famous. We like that.
It starts out with templates.
We were just doing the same thing we were doing with the Casper. They just stated that we measure every part of the MiG. Then we send you the templates, you do the frames, and you bid it, then you send it back.
It's like putting marks on a blank piece of paper, you know, it's just one bead at a time.
There's nothing that is impossible when you put your mind on it.
It was one thing I was looking forward to working with, and one thing I was expecting to be slightly a good challenge for us guys.
Every time the beads arrive, it's that feeling. It's when you're 7 years old and it's your birthday and you're running upstairs to your parents' room and you're tearing your presents open to see what's inside, and it's just so exciting. It's like a brand new red fire engine, you know.
it's really amazing to see things that maybe we've cast parts for, or templates that I've seen made, or, you know, anything really gets sent to the other side of the world and then come back and they're just so fantastic. Every time you think it's going to be amazing, and then it's better.
I used to tell myself I want to be a doctor. I want to heal people. But I found out that even right now I'm doing the same thing. Although it's not medical, but I'm healing people, making people happy. One's happiness is my happiness.
There's something to be said of the team that is working to create all of these beads as well. These are the people that were affected by all of these acts of war, these vehicles of war, and it's almost like taking those things sort of back and changing them into something better, into something that isn't so horrible, by using like their craftsmanship and their hard work and, you know, a lifetime of mastering a particular skill, and you're just kind of covering all of it with that.
Every single day I'm amazed that I get to be in a room with it. It's really powerful, and it's not something you see every day.
You kind of get to a point in your life and you look at the world and you want to do something. I would like to make some difference.
When Ralph sends, when they have glued everything, they've put it in place, I would say, is this us? Is this our work? because it doesn't look like beads. It looks like somebody painted it.
The cockpit on its own is an art piece.
Every possible place there's just dials and switches and buttons and dials and switches and buttons.
It was kind of an enormous undertaking to catalog every single one of these little pieces. We had to take thousands and thousands of pictures and make thousands of little labels that I think were like 4 numerals long.
We decided to do a neat looking seat, sort of in the vibe of 70s lowrider, hot rod.
A sort of nod to the East LA culture that, you know, like outside our studio, you will see hot rods bumping.
We're certainly putting a lot of color and a lot of glitz into the interior of the plane. So it's going to be very bright and very eye-catching for sure.
Ralph has spent weeks really adding this final, like, very intricate touches to them, because now they're like as intricate as the outside of the plane. It's just like a bunch of tiny little details that make such a difference.
You know, after people have already had their minds blown by walking around a jet fighter covered with beads, they can climb up a ladder and get in a cockpit, and then like now they're just like, these guys, you know, like, this is crazy.
We don't forget about the fact that he has a full series of photographs that goes with each project that he does.
With the Casper, he had some interesting costumes made, and they got together and told a story with it. And we wanted to do something similar with the MiG.
Originally, we were talking about doing a flight suit, a high-pressure suit, which was not only going to be a difficult task, but hard to add a bunch of African-style accessories to. We decided it would be cool to do some other looks, like an officer or a military officer or a flight deck crew, ground crew, and that gives us a lot more flexibility in the looks. It's more broadly African.
Some of it came from West African costumes. Some of it came from Central African, East African, the way people paint faces and the ways, you know, like some of the earrings are made out of warthog tusks. These are obviously not real warthog tusks. We've brought in beadwork from Southern Africa, some of the colors and fabrics from West Africa.
Combining that with this sort of repurposed military look. It's actually been a lot better to broaden the horizon of all the different looks we can do.
And it's made things go by a lot faster. But along with that, we still have had the freedom to really experiment and to really take it further and make things way more intricate than maybe we initially thought that we would.
On this one, Ralph and his team, they went, what do you call it?
To the next level.
To the next level, not even the next level, to the next level.
Yeah, I'm looking forward to Ralph bringing in bigger projects.
I don't see anything after the plane that can be huge. Maybe, I don't know, maybe a White House, building a White House, I don't know.
It's so much more than just, you know, a plane with beads on it.
When you blow things up, everything turns brown and gray and the colors are gone. So to bring that bright flashiness on top of the message is really cool.
Knowing like the effect that it has on me, even just, you know, unfinished or partially finished the way it is, I know like the effect it's gonna have on people and children and everybody who are going to get to see it. And that's just really, really cool to know that this is going to be a big deal. People are going to really have their lives enriched by it and really see something that they've never seen or thought of before.
We are not defined by where you are coming from. We are not defined by the borders. We are defined by Ubuntu. our humility.
Okay, next we'll have another video, and this is a conversation that Ralph Zeman and his team had with Embry-Riddle this fall. So this is about half an hour, and at 4 o'clock we'll end the symposium with a chat with the exhibits developer at Museum of Flight, giving an update about the current exhibits they have at the Museum of Flight and answering any questions anyone may have about the challenge of displaying the MiG-21 or about the current exhibits that they have. So let me start our next conversation.
Hi, thanks so much for having me. Really appreciate it. And thank you to everybody for being here today. The first thing I want to address is the irony. I come from a family of engineers. My father was a civil engineer. My oldest brother is a building engineer. My youngest brother is an electrical engineer. And my middle brother is a computer engineer. I was terrible at math at school, and really the only thing I was good at was art. So I find it ironic that here I am talking to the future aeronautic engineers of the world, being the black sheep of the family. When I left school, I worked in film. I made music videos for artists like Michael Jackson, Vanessa Williams, Ozzy Osbourne, Faith No More, and so on. And at the age of 50, I did a kind of a career change, and I went back to my first love, which is art. And this is where I started the Weapons of Mass Production trilogy, which the MiG has wrapped up. This is something that has taken about 12 years, and the MiG itself has took about 5.5 years from the time it arrived in our studio to the time it showed up at the Museum of Flight.
Hey guys, I'm Nick Bonamy. I'm the project manager, art director, and team leader for this project. I'm an artist as well, have been since I was a kid, and I went to art school for college. And one of the things that I learned in art school was most artists, they end up kind of finding one thing that they get good at, and then they just do that one thing for the rest of their lives. And I kind of knew that that wasn't like for me. Unfortunately, I didn't want to do the same thing every day, and so I had to support myself in living in LA, and I wanted to do that doing art. So I kind of ended up in the film and television world doing art department stuff, set decoration, art direction, and then I ended up working in practical special effects fabrication shops, doing costumes, props, and makeups for TV shows and movies. And that was all really great. And then I ended up here with Ralph, and it's been kind of like a perfect place to bring all those skills that I've learned over my life to bear on a big, crazy thing.
Yeah, and it's quite interesting how this all came together. We acquired the MiG in Lakeland, Florida, as you saw in the film. They came without service records, and the U.S. military wouldn't use them, so they'd sat on a runway, just gathering dust and being rained on. And we were just very fortunate to be able to have one donated to us. What's interesting is, how modern aircraft and modern fighter jets like the F-35 or the Soviet-designed MiG-21 are the way the workflows seem to be very similar, and you can see that in the photographs. I know, say with the Airbus, you've got wings made in England, you've got wings made in Wales, you've got the tail made in Spain, you've got various parts made in Germany, and it all is put together in France. With the F-35, parts of it are made in Texas, in Connecticut, in Florida, California, and for the U.S. Consumption, they're all put together in Texas, and the ones which go to our allies around the world are put together in Japan. But again, it is very interesting how this all came together, and how similar these workflows are. Even the way these aircraft look, the radar on the F-35, the radar on a MiG-21, the way the wings work, the way the cradles were made, and so on. You can see that the similarities and the workflows are very similar. And just like that, we sourced components from all over the world. We worked with a team in Los Angeles, which ran it. Okay, here you see the afterburn on the F-35 and the afterburn on the MiG-21, which is partially covered in beads. And so the similarities are very interesting. This is the MiG when it first arrived. This is when it first arrived in Los Angeles, and this was where we did our work on it. We source components from, like I say, from around the world. The beads come from Bohemia in Czechia, formerly the Czech Republic. We had a team of men working in Johannesburg, Zimbabwean men. We had a team in Mpumalanga, the eastern province of South Africa, one in KwaZulu-Natal and Durban, and, all came together in Los Angeles.
So Ralph kind of brought me on to work on this project, and we walked into the space, and this is the first thing that I saw was the MiG set up sitting on blocks, and it's like, okay, this is what we're doing. So throughout my experience, I'm used to kind of doing stuff that I haven't done before, maybe no one's really done before, and this definitely filled that idea. And the more of these things you have to figure out, kind of the better you get at it and about doing stuff new. And we had the Casper to start with, which was made in South Africa. I didn't work on it with Ralph. This was done by all the guys in South Africa with Ralph. And they figured this all out. So we had that to look at, and we had that as kind of like a jumping off point. and, you know, a model of like, okay, well, this is what we're shooting for. And maybe if we're lucky, we can like make it a little better. And really the most important thing was to like honor the amount of time and work and the amazing artistry that these people have to do, because it's just like insane the amount of how big all this stuff is, how many beads it is. You know, every single bead's touched by a person, and we want to show it off as good as we can.
And I don't know how I would have done this without Nick. I mean, I was incredibly lucky to bring him on as the project manager, you know, and he came with a whole host of people he knew and his skills from the world of special effects. He brought in costume designers, fabricators, you know, people from all walks of life, which really, you know, it really stepped up the game from what we'd done in the Casper. The Casper we did in the studio, and it was different, but because the MiG was in Los Angeles and a lot of the team were working in disparate parts of South Africa, all of that coordination was really important.
Yeah, so like to start something like this, you know, you kind of just got to sit with it and come up with a process or a series of processes that you're going to follow, you know, kind of like making your own instruction manual, so that you and everybody who's working on it, you know, like has like a series of steps to get from A to B. And one of the first steps was just washing this thing off, because we're trying to glue, you know, 10 million beads to a plane, and glue doesn't like to stick to dirty things or oily, greasy things. So we washed it off a ton, and I thought it would be fun just to show these pictures of, you know, some of the paint that actually we pressure washed off, and it revealed this sexy Polish lady riding a missile, or the livery left over from the Polish Air Force.
So this is a South African studio team. These guys they all come from disparate walks of life. They come from Zimbabwe, Harare. Two of the guys were taxi drivers in Harare. One of them was a preacher. One of them was involved in smuggling cigarettes into South Africa. But they come from the Shona tribe in Zim, and beadwork is not really part of their culture. It is something that they learned as a way to make a living on the mean streets of Johannesburg. So when I met them, they were making animals, they were making curios that they were selling, you know, to tourists by the traffic lights. And, you know, I'd gone up to them and said, hey, can you make an AK-47? And they were like, who's this crazy white guy? What is it that you're doing? But, you know, that was the beginning of a relationship that's now gone on for well over a decade. The second part of this was meeting Tenjiwe Pritin Kokotsi. She is an amazing lady and a force of nature. She's from the Ndebele tribe, who are based in the eastern province of South Africa, Mpumalanga, and that means the place where the sun shines. The Ndebele tribe are known for their incredible needlework, for their beadwork, and this is a cultural skill that goes back hundreds of years, from the time that the first traders came to Africa and were trading beads with the local population. Tenjiwe is incredibly passionate about it. She's passionate about keeping the skills alive, and she works with a team of about 100 ladies who are based in different parts of Mpumalanga. So she would drive around during, you know, once a week or once every 2 weeks. She would collect the work from the week before. She'd pay the ladies. She'd drop off beads. She'd drop off work. And so it would go. But this was a very long trip, a long round trip. Also, given the just the sheer amount of work that needed to be done on this, she started working with a second team of ladies, Zulu ladies, who have different style and different beading skills from KwaZulu-Natal. That is where Durban is. That's South Africa's main port. It's about an 8-hour drive from Johannesburg. So that made up our 4 teams: the Los Angeles team, the Mpumalanga team, the KwaZulu-Natal team, and the Johannesburg team. You know, and it was also, you know, very much about Tenjiwe's collective called Anointed Hands, and her finding the right people to make the right piece, you know, and some of it was incredibly intricate. Here we get into the global supply chain. The beads are sourced from Bohemia in the Czech Republic. The plane itself comes from Poland, but was manufactured in the former Soviet Union. We have linens from East Africa. We have feathers and feather bows from Congo. We have beadwork from the Maasai in Kenya. We have fabric from West Africa, Kente fabric. We have, these teams which are geographically remote. Johannesburg and Los Angeles are almost on opposite sides of the world. There's a 10-hour time difference. We have people from who carry 6 or 7 different passports, 5 different native languages, and we're all working together with one single goal.
So now we can talk a little bit more about these beads, get into a little more depth than the documentary did. Basically, the beads come in these 2 forms, the thread woven fabric beads and then the 3-dimensional wire beads. So I have a little bit of the woven fabric beads here, and this is all woven together 1 bead at a time with thread and a needle. And it comes out kind of like fabric. So this is what covers, pretty much anything that's flat or flat-ish on the plane. And this is the work that's done by Tinjiwe and the women. So we go back now to so basically how this works is with these templates. Next slide. So here you can see Ralph working on the template for the bottom of the wing. So what we do is we make these templates and we glue them to cardboard, and then Ralph can do all the design with tape and paint and markers or whatever to get the point across, and then we roll that up, we send it to South Africa, and then 6 weeks to a year later, we get beads back. So here's this is images of the template for the bottom of one of the wings. Here's some of the flat templates and the vinyl that we cut out for Ralph to work on the designs. And then as we moved through the project and kind of like refined everything, on the Casper, they made templates using, because it was steel, they could use magnets and tracing paper. But for the MiG, it's all aluminum, so magnets don't work too good. So I used a trick that, is common in special effects when you need to template something or costuming, and that's just cover it with tape. So we were able to find some masking tape rolls that are about 2 feet wide, and we basically covered everything that needed to be templated with masking tape, and then we were able to glue like the chevron pattern onto that, and then Ralph could work on it actually on the plane, and that was really cool because it kind of allowed us to see it come to life on the plane. The picture here on the right is when we got our very first shipment of beads from South Africa. Ralph had created templates before I came onto the project and sent them off. And we were waiting for these, and that was the first day that they showed up, and we realized, okay, this is going to work. Like, let's keep going. Let's do more. Here you can see me and Andy working on gluing this big piece of woven cloth beads on. And if you look from all the way behind Andy all the way up to the front of the canopy, that's one piece of beadwork.
And let me just add that probably weighs, 20, 30, 40 pounds? I mean, it's pretty heavy.
At least, yeah.
At least, yeah.
These are pretty heavy. And this shows also a little bit of our process for gluing. I talked about how these processes are important, and you can see a little bit of the butyl that I'm going to talk about later.
Yeah, and there's a lot of responsibility in putting it on, because that piece alone took 3 ladies 5 months to make. So, you don't want to make any mistakes.
Yeah. So the next thing we're going to talk about is like the 3-dimensional wire beadwork that the guys do. So I have a piece of it here, and you can see that anything that needs to be like 3-dimensional or really strong, it's all, instead of thread, they use wire, and then they can use the wire to like hold a specific shape. And so the process for that is similar. We're making templates. The templates are just a little bit different. In many cases, what we'll do is if we can't really remove a part from the plane, we'll make a silicone and plaster mold, and then a plastic and foam casting. You can see the mold on the right, and Ralph's holding up the casting of it's of a different piece on the left, and then we can just send that casting. Ralph can do his design on the casting, and we can send that to South Africa for the beadwork. Another thing that we did often is you can see the leading edge of the wing. We just taken those curved pieces off, and then we'd send those to South Africa, and they can do the framework and beading there based on those pieces, and then they send everything back to us. And here's a picture of it all together with the leading edge wire pieces overlapping over the woven thread beaded cloth on the top surface of the wing. Another thing we do for the wire forms is we'll make like a cardboard sculpture. Sometimes it's just like a really simple part that doesn't need to be molded, and we can make a sculpture of it. But in this case, it's a piece that didn't exist. We knew we needed to plug the afterburner, and we wanted to do that in a cool way. You know, we can't like let birds start living in there or squirrels or whatever. So we made this really cool series of shapes in using cardboard, and then Ralph did his design on that, and then we would send that sculpture, that cardboard sculpture, to Africa, and then they create the wireframe, and we use that for our afterburner plug. I was talking about developing processes before, and the gluing process was something we figured out really early and just stuck with throughout the entire thing. There was a lot of people working on this project, and we needed to make sure, like Ralph said, we never messed up. And it's really easy if you put too much glue, the glue squeezes through the beads and it looks really bad. And so, you know, we had a notch spreader to get that spreads just the right amount of glue every single time. And we use this stuff called butyl, which is basically it's like a double-sided tape. It's really sticky, but it comes off clean. It's used in the entertainment industry art department for lots of stuff. And we use that to stick everything on before we put any glue on. So we can get it in the perfect spot, and then we can peel off half of it, glue down half of it, and let that dry, and then come back later once it's dry and peel off the other half and glue the other half. And that's the process we followed throughout the entire project. We all got really good at it, and it really made everything very consistent and very clean.
Yeah, Nick tried out a lot of different industrial adhesives to see what was best, you know, what would hold up best. He put a bunch of them on aluminium with beads and left them out in the sun for various weeks. We tried Sikaflex, we tried various things. What worked best of all was good old liquid nails from Home Depot.
Pretty much, yeah. So another thing that was like the first big issue when I came in, before we even talk about gluing any beads on the plane, was like, how are we going to move it around? You know, it's covered in glass beads. How do you like forklift it around without crushing everything? So in this case, I knew I was going to need help. And we brought in this gentleman here, Dave McCauley, and he came up with all of these next ideas that I would never come up with. Number one was we needed to cut off the whole tail for shipping. So that was a picture of him doing that. This is a picture of the cradle that supports the entire fuselage and actually has outriggers with wheels that can allow us to roll it around. If the ground's smooth enough, like at the Museum of Flight, we can actually just push it around without a forklift on this cradle. These pictures show the carts for shipping and manipulating the wings First of all, like we had to, while we were beating, we had to be able to like flip the wings over and do either side. So we built these carts that would hold the wings while we were doing that. And also those carts can be used to position the wing to slide it on if we don't have a forklift. So a lot of times we were working on this, we didn't have a forklift. And we could use these carts to assemble the plane without a forklift.
Yeah, I think the other really important thing is that we had to be able to get all of the components, if we were taking it into a museum or a hall, into an aperture which was about 14 foot high by 14 foot wide, and be able to wheel it. And that was, one of the considerations in how the MiG was reconfigured.
And we ship it around on a truck too, so we had to be under, I think, 13 feet for that, including the bed of the truck, in order to avoid having to get special permits and stuff. Another thing that Dave came up with is we actually cut off all the existing landing struts from the plane. So these are the existing ones. And then we replaced them with our own 3-stage hydraulic rams. So what this does for us is it allows basically the plane to be its own jack. Once we get the MiGs on, or the wings on, we can raise and lower it, and it becomes its own jack. So we don't have to be pushing on it with a forklift. We can manipulate it like that. And then it also gives us the option of posing the plane, tilting it up or down, or tilting the wings, which is very scary and dynamic and looks really cool. One of the other things too was the cockpit. We talked about that in the documentary a little bit, and I just knew that we had to do the cockpit because it's just so detailed and it has so many. It's just so cool looking, and it's a reflection of the beads too. The beads are super detailed too. This is just detailed in a different way. So we had to fully disassemble the whole thing all the way down to nothing. We cut out all the wires. It was crazy. Once we had everything disassembled, we did an automotive finish with the glitter and candy on the panels, and you'll see some of that in some of the later pictures. And we also cleaned up the canopy and did a candy paint job on that to mimic the beaded chevrons on the plane.
Yeah, this gives you a really good idea. We felt because the interior was, not necessarily visible from the outside, we could take it to a whole different level. And as I talked about in the documentary, our studio is in East Los Angeles, and there are often lowrider cars outside. So while the outside of the plane was, purely African, we did the canopy to sort of, to mimic Russian stained glass, and the inside was a mixture of, African design and lowrider culture. So yeah, you can see how super detailed we got on the inside, and just had a lot of fun doing it.
Yeah, and like the moral of this story for me is like, this is a huge collaboration between Africa, between the people I know here, mostly from film and television stuff. And Ralph is just like the best collaborative artist. A lot of artists, like, they are very, like, do everything alone, and it's a very, like, solitary existence. But for Ralph, he really is really into working with people and bringing in all these ideas and picking the ones that are good and that work, and just going with stuff, and everyone working together, and till it all comes out like his vibe,
Yeah, I suppose, coming from a background of film, it's a very collaborative medium. You need a cinematographer, you need an editor, you can't write the music yourself, you maybe need a script writer. So, I believe everybody who touches a project leaves their fingerprints on it, and I really do enjoy the collaborative process. I enjoy working with people. When people would say, what you look for in an editor, what you look for in a cinematographer, I always say I look for someone better than myself, and I think I really lucked out on this because we just had an amazing team of people.
Yeah, so in this case, Jesse, one of our costume designers who you saw in the documentary, he did all the upholstery on the seat, and it came out really, really nuts.
Yeah, and this is the regalia. I was kind of inspired by various things that I thought of. If thousands of West African slaves had been taken to Russia instead of to the United States, how might that have changed the culture? What would things have looked like? I was very inspired by the Zambian space program of the 1970s, if any of you are familiar with that. And so we wanted to do these costumes that were at once African, made out of, fabric and beads, but we wanted them to be Pan-African, and we very much wanted it to have this Afro-futuristic look. Even the helmets, you can see the amount of detail that went into them. The one on the left is actually a motorbike helmet. The one in the middle is a helmet from the USSR, probably a MiG helmet of the same vintage as our plane. And the one on the right, I believe, was a Vietnam-era helicopter's pilot's helmet. So, it was creating this fantastical world around the MiG.
And we were doing all this throughout COVID, and then in LA we had the actors and the writers strikes and stuff, and filming and hasn't really bounced back even now. So that's really sad, but also at the same time it gave us there were so many of the best artists that I know who were available to work on this, and it was really great to bring in those people when we needed them, and number one, give them some work to do, but also be able to take their knowledge and their skills and their creativity and fold it all in to just add more levels to this already many leveled, as Tenjiwe said, project.
and having access to such amazing people was something I couldn't have even hoped for, and really I learned such a lot working with them. So that was really amazing as well.
So here's another collaboration, and it's one of those things where if someone has a good idea, it's really good that you have to do it. And so we did this 1/24 scale model of the plane that's almost a bead for bead exact replica of the plane. The texture's a little bit blown up. It's not exactly 1-to-1 for the size, but it's a full color 3D print that is basically five or six pieces. And our costume designer, Rebecca Klicka, who you saw in the documentary, she's also really good with the digital computer stuff. So she figured out how to take a $40 video gaming model we bought off the internet of the plane and get all of the beads and the colors and the patterns onto it. At long last, we made this cool series of models. One's on display at the Museum of Flight.
Yeah, and I suppose just like, the Airbus or the F-35, I mean, this was a truly global project. It was people working across time zones, across different parts of the world, different cultures, different backgrounds, and yet we all came together to make this happen, and, incredibly grateful to the Museum of Flight for having it. You guys are studying to build machines that are going to push boundaries in the future of human capability. You will work in global supply chains with people from dozens of countries, bringing specialized knowledge together. If we can coordinate all of this and bring it together in such an amazing way, I can only imagine what you guys will do in the future. The engineering principles are the same: modular design, distributed manufacturing, and specializing expertise, careful coordination. The difference is, we are doing it in an artistic way and, hopefully to bring, a message of peace, to the world, and you guys will be pushing the frontiers of, aeronautics. So who has it easier? I don't know. I mean, I'm an artist, so I guess, that's my right. As engineers, you're pragmatists, but like us, you're also dreamers. And, it's really been a pleasure, talking to you and just even for me, digging into the similarities of the way this whole thing has come together. And again, I'd love to thank everybody for having us. Thank Nick, thank Cody, thank the university, and, hand you over to Cody from the Museum of Flight.
If I could interrupt just for a moment,
Yeah.
we have one question from Daytona Beach.
Sure.
They were asking if there was any reason or meaning behind the patterns and colors of the beads on the MiG.
Yeah. That's an interesting question. You can tell the tribes in Africa by the way they put the colors, the patterns together. There is no bead factory on the African continent. Every bead, every piece of African beadwork you've ever seen has been made out of beads that have come from Europe and later on from China. Originally, it was Murano glass from Italy, and then it was Preciosa from Bohemia in Czechia, Czech Republic. What I didn't want to do was take patterns or colors or combinations of colors that reflected, say, Ndebele or Maasai or Zulu beadwork. I wanted this to feel like a modern piece of art that was made using traditional African bead skills. And to that end, we threw so many different colors and into these patterns. I wanted it to feel Pan-African. I wanted it to feel postmodern. But what I didn't want it to feel like was that it came from a particular tribe. So, that was it. When I was at school, they used to give us color wheels, and they said, you can't put this color next to this color. You need to put this one here. I just throw everything together. I don't think about it. It's very much an instinctual thing. But the idea was always that it should be its own thing, and it should be a piece of modern art, contemporary African art.
Yeah, we use every single color available, basically, that the bead manufacturer makes, except for we kind of try and stay away from the pink beads, because for some reason they fade a little bit in the sun over time. So it's just, we use all the colors, and that's...
Yeah, like if you were to look at Ndebele beadwork, it's white, it's got a black line, and then it's geometric shapes that are blue and orange. And Zulu beadwork, even for the warriors, and the Zulus are a warrior nation, the men would wear beads that were white, baby blue, and pink. I can look at a piece of beadwork and say that's Maasai from Kenya, that's Zulu, that's Ndebele, and so on. This just had to be its own thing.
So we are going to be joined by Cody Othot, who is an exhibits designer from the Museum of Flight in Seattle and one of the creators of the exhibit that displayed the MiG-21. And hi, Cody.
Hello, everyone.
Going to give us an update. First off, does anybody have any questions about what it was like working with the MiG-21 or working with Ralph Zeman? Don't see any in the chat. That is all right.
Well, I can say that real quick. It was a fantastic collaboration with Ralph and his team and the Museum of Flight here. We worked together for about 7-8 months to be able to put the exhibit together, and it was the first time that Ralph's Weapons of Mass Production series has been on display for the world, and the world premiere of the MiG-21 itself. So it was a true honor. It was very kind of a different thing for the Museum of Flight, but it brought in many new audiences for our museum and was a big hit with our existing audiences as well. So it was truly a wonderful learning experience, and hopefully kind of sets the stage for how we approach creating exhibits moving forward.
Amazing. Yeah, could you tell us about what exciting things are happening at the Museum of Flight right now?
Sure, yeah, we're really in a fun time right now where I'll tell you about our next exhibit coming up that's going to open in April. But other than a new exhibit, the museum is just in a very fun time of change right now with jumping off on some big strategic plan missions and things like that. So just keep your ears out in the Northwest up here for over the next 5 to 10 years. There's going to be some pretty fun changes with the museum. But yeah, I'm happy to share real quick about our upcoming exhibit called Runway to Runway. Make sure I can share my screen here. All right, here we go. Okay, can you see my screen?
Yes, thanks.
Perfect. So after we wrapped up the MiG-21 project here at the museum, all of that was deinstalled and shipped back to Los Angeles about a month ago. And then we immediately started retrofitting the gallery space that was used for the MiG-21 project for our upcoming exhibit that is called Runway to Runway. And this is a feature of flight attendant uniforms from the Museum of Flight's collection. So everything in this display will be from our own collection, no loans or anything like that, which is a very really cool thing for us to be able to just strictly show off the Museum of Flight's collection. And here at the Museum of Flight, one of our strongest collections is our commercial aviation focus. So we have hundreds of uniforms that we can display, hopefully more in the future, but I'll kind of walk you through what this next exhibit is. So it's going to open April 25th, and will run through middle of January, January 18th, 2027, here at the Museum of Flight. And again, it's called Runway to Runway. It's about flight attendant uniforms and the fashions of, the 50s, 60s, 70s, and even in today. So how we approached it is we looked through the lens of what we're calling fit, function, and fashion. And to be able to get to the point of these are more than a uniform to the flight attendants that were wearing them. Each flight attendant uniform is a distinct reflection of the person who wore it, the purpose behind its design, and the responsibilities carried out while wearing it. So I mentioned that fit, function, fashion concept. The fit is really focused on the individuals that wore the uniform. So we talk about either the person that wore the specific uniform that we have or a representative that wore that type of uniform in the time period. So we'll have 13 different uniforms on display, 13 different individuals telling a deeper look into their lives, their histories, their careers as a flight attendant, and really unique aspects of what it was like to fly at that time for their specific carriers in different parts of the country. And again, just everything that you're going to see in this quick presentation is actually from our collection and will be on display. So all of these uniforms are part of the exhibit. The function aspect is really getting into the role of a flight attendant and how it's much more than just serving food and getting people in and out of the plane. There's a lot more complications to the job, especially when you're looking at it from the lens of the 1940s, 50s, 60s, and 70s. Really is a great lens into the women's rights movements and equal rights movements in the 1960s. We touch on a lot of those subjects through the lens of each of these uniforms. So it's really going to be fun to tell a wider history through the lens of flight attendants and their stories. And then we really want to highlight the fashion. A lot of these uniforms were really incredibly made by some of the world's most preeminent fashion designers. We have uniforms that were created by Valentino, from Emilia Pucci, Yves Saint Laurent, and many more. The current Alaska Airlines uniform is created by local Seattle designer Luli Yang. We have one of their uniforms on display. So it's really going to be a cool mix of history, fashion, and really highlighting these cool uniforms. Just to kind of show you our aspect, we're going to have several cases on display that highlight accessories like bags, scarves, and hats, along with the uniforms that we're going to have on display. So we really are making a showcase for our collection here. We're going to be highlighting those uniforms and accessories, and then trying to give our audiences a glimpse of what a permanent display could look like in the future as the museum continues to mark out our future. This is also going to be the Museum of Flight's first multilingual exhibit. which is very exciting for us. We will have every printed piece of content in English and Spanish, as well as in our digital touchscreens. We'll have an additional 5 languages that our audiences can choose from. So we're really excited about this being our first foray into multilingual exhibitry. We'll also have a number of hands-on tactile experiences, which is going to be really fun. People can actually pick up the different fabrics that these uniforms are made of. You feel the different weights, the textures of something from the 1940s to something from now, and then really think about what it would be like to wear those as your day-to-day uniform. We have one of our uniforms were actually made out of essentially paper. They only lasted about 6 months with TWA back in the 1960s because the uniforms were not great for the function and the role of a flight attendant. So we're excited to be able to tell that type of story. We're also going to have a touchscreen database that kind of highlights the Museum of Flight's digital collection, which is a new database that we've just opened this last year that gives a much deeper dive into, airline menus from across the different decades, the requirements and restrictions of what it took to be a flight attendant over the different decades, give a deeper look than what's just in the printed part of the exhibit. That's pretty much it. I can show you, this is kind of how the rooms are going to be laid out in the new space. So if you're up here in Washington or in Seattle, definitely stop by the museum. And again, this will be open from the end of April to 2026 into 2027, January 18th. So we're really excited to open this up in the next month or so and kind of see where it goes.
Fantastic. Thank you. Oh, sorry.
Oh, no, that's it. Thanks, Christy.
That's great. Well, thank you so much for sharing that. And again, the MiG-21 project was amazing, but this is fantastic, this upcoming exhibit. So thank you for letting our community know about that. And again, if you're in Seattle, you should stop at the Museum of Flight and see this exhibit. So thank you very much, Cody.
Great. Thank you, everyone.
And that wraps up our 2026 Humanistic STEM Symposium. Thank you very much for attending.